Chat. Chat, we here. How's everyone feeling? What's going on? Oh boy. I've got no air conditioning, man, in my penthouse apartment. I don't know how I'm going to survive the next 3 hours. I've got a fan next to my face. Alright, okay. And we're here, another year, another extension 2 paper. Yeah, 2025. I hope everyone's feeling like a winner right now. Not a cat reckons they're feeling pretty good. Nice. Discontent with that. Yo, discontent with the paper or with my living conditions? What's the feedback so far? Because I kind of want to like start law accurate student experience. Nice. Yep. So we're gonna like, you know what? We'll set the timer so we can start the reading time on time at 6 o'clock, and we'll finish up at 10 past 9. If I can do my 24-hour correctly. Yeah. Okay, so we'll start reading time in a minute's time. Oh boy. Need to get myself a water. Discontent with how I went. I know I could have done better. Both literally and by the paper. Sheesh. Who's cooked? One's in chat if cooked. One's in chat. Cooked. Goodbye 99.95. Sheesh. I'm not sure I'll do 2 unit. I'm like, cause it's already too late. Cause it's been like half a day since 2 units come out. So unfortunately, no 2 unit. All right, guys, let's start our reading time. I'm gonna use the laser pointer to talk about the questions. Do I have a calculator on me? Yeah, I got a calculator. All right. So what have they got in store for us this year? Vector equation of a line. Wow. Okay. Nothing crazy. Negation. Yeah. Easy. Square roots. Okay. Has simple harmonic motion. What is the amplitude? Yeah. No dramas there. Consider the statement. Contrapositive. Nice. So they're giving all the proof remarks in the multiple choice. What's the modulus of Z? Oh. Well, that looks dodgy. Like you'd have to kind of do it to deal with number 6. What's the modulus of Z minus W? I almost feel like you need to kind of draw it, eh? Like, I guess we'll find out, huh? We'll have to find out what we're doing with number 6. It's always starting with 6. And then, what's this? Another unit circle one? Alright, okay. Another unit circle. What's the range of this? Yeah, look, I mean, you could just like muck around with the vector and talk about, you know, tangents and stuff, I guess. They've given you pretty nice angles, not gonna lie. Okay, the graph shows the velocity of a particle as a function of its display. Oh, that looks interesting. No one ever graphs it. Why would they do that? That's kind of rude. Okay, so number 9, given that what quadrilateral best describes this quadrilateral? Oh, can you guys believe it? I was just helping like a year 12 child yesterday, you know, like on the properties of year 8 quadrilaterals. It's amazing how little. You reckon it's COVID, guys? Like, cause 2021 was when you guys had like COVID, and you have no clue what makes a rectangle or a rhombus. It's funny how they put that as a question 9. That's amazing. What do you guys think? Question 9 on properties of quadrilaterals. Amazing. And question 10. Oh, this looks dodgy. This looks really dodgy. I haven't, like, how do you like just put that in Desmos or something? Except you don't have Desmos during the exam. Okay, so who knows? Magic mushroom. Hi, welcome in. We just kicked off the extension 2 reading time, and we're right on time, starting at 6 o'clock. Okay, so question 11, we got a bunch of stuff. You got to draw something apparently on the booklet. I didn't have that booklet. Do I have that book? Did I just, wait, did I bring the booklet? That would be so bad if I didn't bring the questions. Because once we get to writing time, I'm not going to be able to show the questions on the screen. I just haven't got the tech set up for that. So we got the booklet and I can see, okay, they gave you a little Z in the little corner. Not an issue, we'll just do it ourselves. Okay, modulus and argument. So it's pretty trivial, I'd say. Finding Cartesian form. So a lot of free marks in question 11. 12 in the director. Oh, and they even give you like a show. So that's sweet. You can just do the unit vector and go from there. Forces. Both act upon a particle. So resultant means add. So I really don't think there's anything happening here. Wait, what? Did they just ask you to like... Guys, is this a new and extension 2? You can just literally add. Can you imagine just adding to get 1 mark? Damn. Calculate f dot d. And they gave you d. So they gave you like a free mark for doing the dot product. Nice. Wait, what's this? What's this, guys? Prove this by contradiction. So, wait. Could you technically like set up the negation and then just say the left-hand side is smaller than the right-hand side because of the calculator? I'm pretty sure that's not what they intended, but could you? Like, I reckon it's contentious, guys. Number 11E, that's like, it's a little bit dodgy to me. Okay, so you got an integral here. By parts, another integral. They're spamming these easy integrals right off the bat. Mathematical induction to prove this business. I don't like this theorem, just generally. I just think it's, yes, it's the induction language, but, you know, do whatever. Region of the plane, this looks like a perpendicular bisector, so it's just which side of the perpendicular bisector. Partial fractions, a bit of integration, you know, probably VdV/dx kind of stuff going on that one. Oh boy. Oh, okay. Hold up. So you got a equals this thing. It's like an integral, and then you want to show that this are constants. Wait, you want to show that this is a multiple of a. I mean, I can see how these limits are kind of like linked to these limits with an appropriate substitution. So I don't really think this is going to cause us any issues, but I think this is a tricky question to put on 13A. Like, I don't know about you guys. Any comments in chat about the nature of question 13A? I think 13A is sus. It shouldn't be there. It's a bit harder than where it should be. Tell me what you guys thought of it, because I can see through it straight away, but I know that this is going to cause people problems on 13A. Possible vectors. Wait, hold up. So you got unit vector perpendicular to them. Okay, so you set up the dot products equals 0. You're going to get like an equation with 3 variables with nothing to solve it with except a condition that the magnitude is 1, and that's a 4 marker. I wonder how that's going to be distributed. This is not looking good, guys. 13A and B looks like they look dodgy. Who reckons 13 is dodgy? Who reckons just 13 is dodgy so far on 13A and 13B? It looks sus. I don't even know. Okay, 2 marks for an AMGM basic proof, and then it says hence or otherwise. Alright, what are you going to do with that? You know, it's like, it's just working backwards for that sort of question. You know, you can be funny and do something different, but like working backwards will work just fine. The square roots have to be dealt with immediately. It has to be. Yeah, so that's what are you going to do? This one, it just looks like one of those ones where it turns into like a 2r equals kind of situation. So I'm not going to say much more about that one. We've got about 2.5 minutes of reading time left, and I'll start writing out the answers. Okay, so in integration with cot, it's been a while since we've done cot. We've done like tan to the power of n. We've done like, you know, it's about like splitting off like powers of these things. It's not really by parts because you don't want to introduce any new letters. So yeah, it is what it is. Okay, so another integral. Roots of unity. Find the other root of this. I feel like I've seen this before. Isn't this in like one of the old HSCs? I've seen this in like 2005 or something. Yeah. Like I swear I've seen this in one of the like a decade or two ago. They did this one, exactly that one. Okay. Consecutive terms in an arithmetic sequence, a common difference k, where k is a real number and k is greater than 0. Show that b plus c is less than a plus d. Look, it's a bit special. I would say that for a 14D, it's a bit special. There's something like creative going on here that we can discuss when we get to it. Sides of a parallelogram are represented by these vectors. Show that the area is this. This is like a standard thing. If you learn how to do it, you know how to do it. If you don't know, well, you know, then you don't. Simple harmonic motion with origin with amplitude A, 2 cycles per second, or you better know what frequency is, right? That's cycles per second. It's a frequency kind of thing. That's the second time they've done frequency in the nested papers so far. Okay, this one. What's this? Prove this is ICOT. This is a standard proof, guys. You would have seen this in some textbooks. I reckon the Mastering Mathematics will definitely have this one as one of their main examples. If you have the Mastering Mathematics textbook, this is definitely in their examples. They've actually shown you a couple of good ways of doing that as well. Okay. Consider this equation. Use proof by contradiction. All right. So we're on the 16s, and I'm only got 20 seconds of reading time. Look, it's too soon to be looking at 16s and thinking about them. Like they kind of look very wordy, and that's all I can say about them. Oh, a vectors, last question in my HSC. Okay, all right. Very interesting. I had to read it. We have to read it. All right, guys. So we're going to start doing the multiple choice. I'm going to do it on top of the question paper for the multiple choice, and then we'll put the multiple choice answers on the column on the right. Here we go. Question 1. Vector equation. Okay, so we got vector b, direction vector, equals to 3, comma, minus 4. No, guys. All right. In your first question of multiple choice, you've got to make sure you can do arithmetic. Let's do it slower. Let's go slower. 4, 1, minus. No, I can't. Wait. 1, 4. I can't even do them the right way up. Holy. I'm just warming up, guys. Warming up. Is Epic Math going to get cooked on question 1? So we got a direction vector, and there's only one answer that's got this direction vector, and it's D. Okay, all right, lock in D, guys. We've got D for question 1. And question 2, negation of the statement. There exists an x such that x squared is odd. Negation, so for all x in the integers, comma, like I guess, fine. B. What are the square roots of this? Look, you can just do it by inspection. I think you can just like square each of them and get that one. You know that one's the negative of the other, so you can just square it. I'm gonna say this one's no good. This one's no good. These two look pretty good, but I think it's this one because that one doesn't square to give minus 4i. So it's this one, C. 3 is C. Okay, that's it. Done. A particle in simple harmonic motion has speed, blah blah. What's the amplitude of the motion? Look, you can just do the endpoints, right? You can just do minus x squared plus 2x plus 8, x squared minus 2x minus 8 equals 0, x minus 4 and 2. So these are your endpoints, 4 comma minus 2. The distance between them is 6, so the amplitude is 3. Number 5, consider the statement. Contrapositive. If x is greater than 0, then that, it's just this one, right? Moving on. Okay, now this one, they lie on the unit circle and the modulus of z plus w is 3 on 2. So you got a 1 here, you got another 1 here, and you got this guy, which is the diagonal of the parallelogram, is a 3 on 2, and therefore halfway across is a 3 on 4, and therefore by Pythagoras you got 1 squared minus 3 on 4 squared, giving you a 7 on what's it called? We'll do the square root since we got 7 on 16, so 7 on 4. 7 on 16 square root, so root 7 on 4, double that is root 7 on 2. Okay, that's not easy, guys. I actually feel like number 6, you actually have to know what you're doing. Like, you actually have to know the diagram of what these the vectors actually mean. Okay, it's Pythagoras, another quadrilateral property. Okay, diagonals bisect each other on a rhombus at right angles. Complex number lies on a circle. What's the range of this? So argument minus 2i. So minus 2i means vectors coming out from this point, and you've got this one and another Pythagoras-ish type thing. You got 2 and you got a 1. So this is a 2 and this is a 1, so this is a 30 degrees, and that means the lowest argument, right, if you treat that as your axis, is minus 60. And there's only one answer that's what? Hold up. Principal argument. What am I looking at here? What? What am I doing? Oh. Let's just pause for a second here. Okay. Argument of z minus 2i. And z lies on the unit circle. Oh, okay. Yeah, okay. So you can even get a lower one, like another 30 here. So minus 120. Minus 120 is only like that one, that option. And, oh, okay. So it's just between here and there. That was the highest value. I'm just being silly. Okay, here we go. So that's D. Number 7's D. Number 8, something dodgy here. We've got V and X. Shows the acceleration of the particle as a function of the displacement. We need to square the function first. So we got V squared versus X, because we need to differentiate that in a second. Squaring that gives us this thing, and it goes a little bit higher, maybe. I don't even know. It doesn't really matter. And it goes up a bit higher, and then bounces off and goes a bit higher. Okay, that's V squared versus X. And then you're going to go D, half V squared. No one cares about the half part because the shape looks the same. You're going to have to differentiate that, which means that you're going to be looking at something that looks like the gradient function of this thing. So we got an intercept here. So we got intercept here, intercept here, intercept here, intercept here, intercept here, and it all goes through because they're all stationary points. It's like a 2-unit question at that point. So I've got 1, 2, and parts negative. Oh, literally advanced maths, guys. We're in advanced maths territory now. Plus, plus, minus, plus, plus, plus. Okay, so in the end, we got a bunch of pluses. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This looks right to me. Let's just make sure that the other options don't offer anything useful. Nah, so A is the answer for number 8. Number 9, the points represent complex numbers respectively. It is given, oh, okay, this is interesting. This looks like the arithmetic mean question. It is given that V plus Z equals U plus W. That's interesting. V plus Z equals, I can't actually see like what's going on. Like I can't visualize this thing. Guys, like I'm not actually sure what's going on here. So I need to think about this for a moment. K-I-Z. K-I-Z. Why? Why is that? I'm just going to start with a V plus Z. I don't really like the look of the way that they've arranged it, so I'm going to rearrange it into V minus U equals to W minus Z. That's the first thing I'm going to do. And that just shows you that they're parallel and equal. Okay, so these relative vectors are all good to go. And we also got U minus W equals to, I'll go the other way around. Let's go like the other way around. Why is the thing not working? W minus U equals to Ki Z minus V. So what's the deal with that? It sounds to me like, you know, if you got U over here and you got V over here, U to V, this vector has to be the same vector as Z to W. So you got parallel and equal because they're the same vector. So it's already a parallelogram looking thing. We also know that just changing the color up a little bit, Z minus V, this guy, is a Z minus V, okay, is a scalar multiple, but at right angles to W minus U. So what that means is there's a right angle there, but not equal. K is not 1. So that means this is not a square, because a square will have equal diagonals. Therefore, and the diagonals are equal and so perpendicular to each other, and it already is a parallelogram, so that makes it a rhombus. I mean, like, come on, the diagonals are perpendicular. There's only 2 shapes that do that for you guys. That's the answer to 9. Which of the following gives the same curve as this? To be fair, that is tricky. Like, that was not nice. That was not nice. Which of the following gives the same curve? It's a question 9 for a reason, guys. Now, guys, I know you can sub in values, but this is question 10. Okay, so you got to give it a bit more respect. I actually don't know. I actually don't know what this looks like. I'm sort of looking at it and thinking like, yes, we can sub in values. Yes, it'll contradict by subbing in a value, but the point is that you can make t a bit smaller and it will still work. This one does not work. I'll tell you why this one does not work. Because when t traces out a value and you make t a bit smaller, right, having a minus t, it can interact with cos in a good way, and that the minus sign will go away because of the nature of cos, but the sign is just wrong, okay, because the minus sign's not going in. That's no good. So the way I'm looking at it is that I'm already seeing what they're trying to go for here, is that the t stuff, that stuff is irrelevant, guys. That stuff is matching between all the values, but what you got to understand is you got to know your like identities. So for example, cos of that is actually, I don't know if you know this one, guys, it's minus sine of t squared, okay? And you just think, oh, like, what's going on here? Like, I can't tell. I can't tell. And I don't like these t-squareds. I'm not a fan of these. There's something awfully terrible about the t-squareds, because when you go to like the negative t's, you're like, the problem with these guys is that you're not going to get positive, okay, like these guys will always have y values less than or equal to 0. Whereas this one, t is real, right? So this one's out because the y values are always greater than or equals to pi on 2. Okay, and that one's out because y values are always greater than or equal to 0. So b and c are out. So basically the only thing you need to do is suss out a or d, and I don't like a because a's got some crap that's like this minus sign, it just doesn't gel with the sign. I think it's going to go the wrong way. So my intuition is that 10 is d, but there is a good reason why it's d, everyone. And let me try to explain to you why there's a good reason why it's d. Wait, isn't it obviously? It's, oh. Yeah, see that minus sign that snuck out, guys? Guys, there's only one reason why it's d, and it's that minus sign that made a not work. Like, no one cares what t is. T could be replaced by a dummy variable of 2t plus pi on 2. No one cares, right? What you care about is that when you put 2t plus pi on 2 in each of them, okay, there's the minus sign here got flipped. Okay, so we're saying minus t is 2t plus pi on 2. Okay, so what that means is that if I do that replacement, probably should use an arrow here, huh? So minus t replaced by 2t plus pi on 2. T is going to become negative 2t plus pi on 2. And the only function that brings the negative sign out is the sine function. The sine of minus bracket 2t plus pi on 2 will get the minus sign out. So thank you, Nessa, for giving us at least a clean multiple choice question set, because 2022 was an actual joke. Okay, so it's D. So we're just going to put up the multiple choice answers on the column on the right, and that's pretty much it for multiple choice. Okay, here we go. So unless I've made some ridiculous arithmetic errors, we've got 1 is D, 2 is B, 3 is C, and 4 is B, 5 is A, 6 is B, 7 is D, and 8 is A, and I have very clear explanations on why they're all the answers that they are. 9 is C, and 10 is D. So those are our multiple choice answers on the right of the screen. Tell me how you went, guys. Give me a number. What do you guys think you got out of 10? 1 out of 10, like 0 to 10 in chat, guys. What y'all getting for the multiple choice? Question 8 was A. Yeah, question 8 was A. Okay, I am so cooked, Gian says. Yep, question 10, good. 8 out of 10. Let's go, Peter. Let's go, great. 8 out of 10. Well done, everybody. Ringo Mark with an 11 out of 10. I don't know how you do that. Like, did you come up with an extra, like, insight or something? Nice. Yotan's 9 out of 10. Ringo's, please, Ringo, sit, Unk. Ranath, 5 out of 10. Oof, Ranath, you did the paper last year, so I'm not sure about that. Guess 3 of them correctly. Oof, good one, nice one. GMP 2007, 10 out of 10, very nice. Escape Sam, 5 out of 10. Oof. Oof. Okay. I'm failing multiple choice, bro. Did you see the advanced paper? I saw the advanced paper. It looked kind of hard. I'm not gonna lie, it looked hard. Yeah. Ouch. Getting dehydrated already from doing that. Oi, who are you calling Unk? Ha ha ha. -4. Ouch. 6. Frowny. Tyweb. Yeah, okay, Tyweb. Alright. Alright, let's go. 6 or 7. Nice. 6 or 7. Alright, guys, we're going to write the answers up on the other section. I'm kind of looking forward to trying these last sections because I'm not sure how they're going to go. Here they are. Hopefully it's not too much. Okay, so they've given us question 11. They've given us a little Z over here. And 11A says locations of, okay, so here is Z. Here is the thingy of Z. Conjugate, that's what they call it, yep. And then here is the 90-degree rotation anti-clockwise of the conjugate. So, I mean, I hope people put in a right angle there just because, you know, just to play it safe, yeah? Okay, 11B. The complex numbers WZ equals to 6e to the power of I pi on 3. And therefore the modulus of WZ equals 6. And the argument of WZ, they didn't say principal, but I think they're just happy for you to give just 1. So it's fine. Number C, Cartesian form x plus iy, so z squared equals to 2x plus, wait, I mean x squared, guys, sorry. Yeah, minus y squared plus 2xy, and then part 2, 1 over z. They want it in Cartesian form, so I'm going to guess that they just realize it. Got x squared plus y squared. Okay, well that's it. That's fine. I don't really think they care if you don't turn it into like individual like parts, but we'll write it anyway. Okay, so that's question 11C. My fan is like blowing the papers everywhere. Go over here, I think. 11D. D part 1. Force F1 has magnitude. Okay, so we got F1, vector F1. We just had it. So 2 minus 2, 1. divided by its modulus, and then times by 12. Its modulus is going to be the square root of 4 plus 4 plus 1, and we times it by 12. That's root 9, so that's just going to be 2 minus 2, 1, times by 12 on 3, which is 4, so that's 4 times, and that gives us the answer they're asking for. So 8 minus 8, 4, as required. D part 2. D part 2, show that the resultant force acting on the particle, I think we just add F1 and F2 if you know what resultant means. So it's really chill. Like, I mean, I don't know how much working you got. Wait, how much working do you have to do for this one? Like, to get the 1 mark? It's so obvious that you almost have to like spell it out for them. That's why I'm writing this, guys. I'm gonna get 2 minus what, huh? Oh yeah, I can't add. Sorry, it's plus 4. 8. Yay. Okay, in part 3, calculate F dot D. So with the resultant force, so we're going to go 2, 4, 8 dot product with D, and D is 1, 1, 2, and that's just going to be 2 plus 4 plus 16, which equals to 22. I think. Yeah. Cool. And the question E, prove by contradiction. So guys, I think all you have to do is, because they already said contradiction, they expect you to do a proof and not say the calculator. So all you got to do is just say, assume the negation, which is this. And because both sides are positive, you can square both sides. Therefore, you say 3 plus 5 plus 2 root 15 is less than or equals to 11. Rearranging it, 2 root 15 less than or equals to 3. And then root 15 is less than or equals to 3 over 2. And since there's positive on both sides, 15 is less than or equals to 9 over 4, which you would say, hey, let's just make it really clear for them. 9 is greater than or equals 60, which is false. Therefore, the original statement is true by contradiction. Okay, I feel like that's about it for that one. And it's a bit silly. I think they got sick of doing like the irrationality proofs, so they kind of just went for this instead today. Okay, so this one, okay, so I like to do this really fast, but don't know about you. I'm gonna go minus, and I'm gonna have x plus 3 in brackets all squared. Okay, and because I know that I don't want a 7, I'm gonna, like, that's gonna be a 9, so that's gonna be a 16, and that's gonna be about it. Do I know the formula for this? It's like a 5 inverse sine of x plus 3 on 4 plus c for 2 marks. Yeah, just double checking the numbers for a second. 16 minus 9 is 7. Yeah, that's fine. Okay, and there's no like reverse chain rule going on here. All good. Okay, so that's 11 done. We should probably start a new page for question 12. Question 12. How are we all feeling, Chad? What's all happening? Chance to read chat instead of continue emphasizing the 2xy issue. Oh, 2xy is like the coefficient with the I signaling that it's imaginary. Have I stuffed up question 11, guys? What am I doing? Find in Cartesian form. What's wrong? Guys, what's wrong? Oh, yeah. Oh, yeah, true. Hey, that means I've lost a mark, hey. Wow, guys, we're not getting Hemisphere rank 1 today. That's nice. All right, cheers. You reckon a 99 raw to 55 raw to 90? Surely not, David. 2xy. Drop the I on the 2xy. Nice one, guys. Nice one. All right. Thanks, chat. Guess we lost 1 mark on our HSC. Good job. All right. Use integration by parts. Thanks for letting me know. We got x sine x dx. Okay. And we're going to integrate the sine x, so minus cos x times by x, 0 to pi on 2, minus, now because it's minus, we have the plus again, and the cos x times the 1, so it's just 1, 0 to pi on 2, dx. Put the pi on 2 in, it's gone, so that's a 0. and then you're going to have the plus the integral, so the evaluation of sine x from 0 to pi on 2, which is a 1. So that's just 1, guys. 12a is 1, unless I'm wrong. Chat can help me out here because I'm not going back to do these. Okay, so y equals to x e 2x. Use mathematical induction to prove that. Okay, so we're just going to do d1s. For n equals 1, we've got dy dx equals. So you got to do product rule, unfortunately. So vu dash, so e to the 2x, plus uv dash, so you got a 2 times x times e to the 2x. Okay, and what we are doing is that's your left-hand side. And then the right-hand side, by subbing in n equals 1, is going to be 2x plus 1 bracket e to the 2x, which is the same as what we got on the left-hand side. So true for n equals 1. Not bad. And then we can say assume for n equals k dot dot that the nth derivative of I should have written k dx with a k is equals to their answer, so 2 to the k x plus k 2 to the k minus 1. Like, you know it's gonna work, but it's just like a hassle writing it out. This is the assumption, and you want to do RTP that d to the k plus 1 of y over dx to the k plus 1 equals to 2 to the k plus 1 of x plus, it looks such like a pain. Why does anyone in a right mind want to do this? Awkward, isn't it? Okay, so that's your +1 case, and we want to prove that. Let's just quickly check. 1 on z equals conjugate of z. Good one, Sam, good one. Realize quick that it wasn't like a unit circle. Ouch, I forgot to do one of the questions. Q11, that was like 1 on z. Yes, whoops. Instead of arc. Did I write? Am I going through this too quickly? Inverse sine, guys. So that means I've lost 2 marks already. We're down 2 marks raw. That's ridiculous. I blame the iPad. Left hand side equals d dx of what we got. So we're just going to write the assumption in a second. d dx of this whole pile of stuff. Now you got to understand that all of this is just x, so there's nothing like too crazy about it. We're going to do a product rule. We're going to use v as e to the 2x again, and u dash as the other thing, which is just do the k for this part, plus 2e to the 2x times by the vu dash plus uv dash. So we got 2kx plus k, 2k minus 1. You factorize e to the 2x out, and you're going to get 2k plus 2 to the k plus 1 of x plus k times 2 to the k, which makes it k plus 1, and that's the right hand side. So, okay, so it looked really scary for a little while, and it turns out just like induction, as induction would turn out as required. Therefore, true by mathematical induction. Okay, so there's our induction. Thought I cooked MC after the exam, got 5 out of 10. Oh man, that's bad luck, Cooper. Bad luck. Who reckons the advance was hard? I thought advance was hard, guys. I thought it was pretty nasty. This question was on a 2023 VCAA. Ah, yeah. So NES is not that original after all. Okay, fair enough. Sketch the region of the complex plane. We're going to do that one real quickly. So question 12C. Do it over here. Z. I'll just change it to the correct form. Z minus 5 plus I greater than Z minus 3 minus 3I. I just don't like all these minus signs. What are they doing? Have I? No. There's like an extra minus sign here. Okay. Wait, what? No. I hate minus signs, guys. It's artificially like wasting your time. The guy can't even manage his minus signs. How is he going to do questions 15, 16? Oh man, I think that's the right minus sign in the right places. Yeah, I think so. We got it, guys. All right, okay. So here are our points. -5 plus I over here. And 3 minus 3I over here. You probably should find their midpoint. So we're going to like get their midpoint real quickly. And the midpoint is just by adding the coordinates. And that's going to be -1. -1I. I've definitely done this out of scale, haven't I? So we'll put it around here. -1 minus I think. And of course, the dotted line that we're interested in is the perpendicular bisector. And that's going to be a 90 degrees there that you should label in very carefully. Now, obviously the statement is that it's closer it's further away to -5 plus I, so it's this region. And if you did that, it should be totally fine, right? So that's 12C, 12D. I'm gonna go straight into the A over, oh, they got a minus sign in that one as well. Rude. Bx plus C over x squared plus 1. Okay, and obviously we would very much prefer that A x squared plus 1 plus bracket 4 minus x bx plus c equals to x squared minus 2x plus 9. Let's not mess up the algebra. I forgot to shade. Oh, GM forgot to shade. Oh, bad luck, brother. Overcomplicated 12C. Look, honestly, if you used x plus iy and simplified it, you should have still been okay. I actually don't think it's that bad. Bad news as long as you did the question. For this, I told so bad. Damn it, retro. Bad luck. Alright, so we're going to let x equals 4. That's a dodgy number. Like 17a equals to... What are we on about? That's 16 minus 8. Oh, okay. Alright. Well, a is 1. Nice. Okay. So therefore, we've also got the coefficient of x squared, which is a minus b equals to 1. Therefore, okay, b is 1. I guess b is 0. I'm sorry, b is 0. Because like 1 minus b equals 1. I can't be bothered writing that. Let's just leave that out. Okay. B is 0. And lastly, we'll just let x equals 0. So we got a plus 4c equals to 9. And 4c equals to 8. C equals to 2. So we have all these things, and we're integrating indefinite integral, and a is a 1. 1 over 4 minus x plus c, which is 2 over that thing, x squared plus 1. Okay, leaving us with negative ln absolute value 4 minus x plus 2 inverse tan of x plus c. So nothing going crazy here, pretty simple kind of question. Now I'm just going to use the space that I've got underneath this question to do E so that you've got more stuff on your screen. A particle of mass m moves around a horizontal line with an initial velocity of v0, resisted by a constant force of mk newtons and a variable force of this. Okay, so we say F net, because it's moving along a horizontal line with initial value, it didn't really say that v0 is negative, which is I think a little bit annoying, but because it's v squared, I'm just going to say that the right is positive. So we're going to go minus mk, okay, minus mv squared because it's resisting. But we don't actually know whether v0 is positive or not. Does that matter? Guys, what do you think? Like, do you have to do 2 cases to do this question thoroughly because they didn't say that v0 is positive to begin with? I'm kind of concerned about that, to be honest. Because it changes how you would write the acceleration. Not really, not really. Does it? No, no, it will just add up to the same thing, but I'm still a bit worried about the nature of this. I'm not a fan that we're assuming that V0 is positive. What does chat think? What does chat think? V0 positive? Is that an assumption that you're allowed to make for this question? So we got A equals to minus K minus V squared. There's a squared sign there, my bad. They did do a square sign, didn't they? And yeah, okay, we're going to assume V0 is positive. It's only 3 marks on a question 12. You can't like overthink this sort of thing. So V dv dx equals to minus K minus V squared. I want to keep the minus sign on this side, so minus dx with an integral sign, and V over K plus V squared on the other side, integrated with dv. So we're going to get a log on this side, so a half ln absolute value of K plus V squared equals to minus x plus c. And we know that the distance traveled when the initial velocity is v0 is basically 0, so we sub that in to get c. Half ln k plus v0 equals to c. I guess we can just like move things around, but I'm kind of worried about something. Oh, okay, well let's just write the equation out because we have to sub one more thing in, and that should have been fine. Minus x plus c, which is a half this. I can't even be able to rearranging because we know what we're going to do next. We are going to let v equal 0 and say that x would have been a distance traveled, which is a half absolute value k plus v0 over k, because you minused it over. Because it's a show question, I'm actually going to spend a little bit more time just minusing that term over and showing that k part. And I'm also going to write a little statement at the bottom, although there's a log that I forgot to write. Okay, now I actually think this question is fraught with an issue. We're saying also, similarly, if we treat it that way as positive, if initially v0 was negative, like everything applies similarly. And we're just going to claim that and not even check it because the question's only worth 3 marks. So that's the end of question 12. Okay. So chat, what do you guys think? How are we doing so far? We've lost 2 marks from arithmetic errors. How are we doing? V0 squared. Yeah, I'm just not writing everything out today. I'm just not writing everything out, which is kind of crazy, isn't it? Like I'm literally not subbing in like stuff, like really obvious stuff. But that's just me. It's the iPad. Like sometimes you just kind of can't see what you're writing. What do you guys think? Did anyone else have this question running in their head when they were doing the situation? Because who's to claim that V0 is positive? You're gonna make it, yeah, I'll do that, TyWeb, not a problem at all, not a problem at all. Okay, because it then gets reversed by the opposite direction resist, exactly Red Dragon Star. That's why I made this statement at the end, because I just thought it will be, like, I don't think they'll assign any marks to it. It's gonna be fine. As long as you did it one direction, it's fine. Okay, so question 13, let's get to it. Question 13. So we've got this dodgy looking integral here with a equals to 2 to 4 e to the x over x minus 1 dx. For 3 marks, you have to show this thing. Now, my opinion about these questions is that they're always like, it's always a dummy variable situation because these limits just don't look like your friend, right? So you just think 4 must be m minus 2 and 2 must be like m minus 4 at some point, at some stage. So how do you even like make that happen, right? Like at some stage that's going to happen. And to me, the way to make that happen is you say, okay, somehow like, somehow if, okay, let me say it in a different way because I don't really like this. If x was m minus 2, okay, then u should equals to 4. If x was m minus 4, then u should equals to 2. So what that means is that for this to happen, you basically need u to be some function of x that helps you do that, and the most obvious one is x minus m. Now, I honestly think that that's like, I actually don't think it's true, guys. I don't think you're going to get 4 out of doing that. I almost think it's better to like go like plus 2 question mark. Let me think about that actually. Minus 2 plus minus m minus 4 u equals 2 plus 6. Are you for real? Why would anyone do this? All right, guys, can I just demonstrate what's going to happen if let u equals x minus m plus 6, guys? Like, that is ridiculous. Okay, so when x equals to m minus 2, u equals to m minus 2 minus m, which is minus and plus 4. Yeah, cool. And when x equals to m minus 4, u equals to m minus 4 plus 6 is 2, tick. Okay, very nice. And dx equals to du. Okay, and we can make x a subject, so u plus m minus 6 is the correct substitution. So here we go, guys. Now, by doing this substitution, we turn this into du, we turn this into e to the power of u. I don't like this minus sign, to be honest. I actually don't like this minus sign at all. I think something's terribly wrong here, but we're gonna just like power through it for a moment just so I can show you what I'll do next, because it's not working. Okay, and then because x equals u plus m minus 6, it's gonna be like u plus m minus 6 minus m plus 1, and that's gonna be 2 to 4. I got what I wanted here, but I did not get the minus sign out. So let's just find out what I'm doing here. E to the minus u times by e to the m minus 6 with a minus sign. Not good, not good. You've got a u minus 5 on the bottom du, which means that even if you did the thing, you're not going to get x minus 1. You want this to be x minus 1. So we scratched that. We got too creative here. We did not need to do this. Okay? So my next intuition is that if x equals to m minus 2, then you need to be a, well, I mean, like, it's probably the other substitution that was far more obvious. We probably would have tried that first. This is the one we want, okay? So that means u equals to x minus m. I mean, I said it earlier. I was just trying to be really clever, trying to get the limits to be exactly 2 and 4. So we're going to do that instead. Du equals dx. Okay, x equals to u plus m. Amazing. And that's just going to give us minus 2 minus 4, because that's going to get, like, I mean, I still think something's wrong with this, to be honest. Like, I still don't believe it yet. Hold up. I still don't believe it yet, guys. I think something's terribly wrong here. What am I not doing right? Guys, I'm stumped on question 13a. This has never happened before. Like, whoa. Oh, man. Oh. Alright, guys, we're getting held up by 13a. Alright. Lock in. Do not tell me. We want x minus m, so that's out as well. We want x minus m plus 1 to be u minus 1. Really? If x equals m minus 2. Oh, because they've always got a gap of 2. Well, of course they always just got a gap of 2, but why? Guys, I don't know how to do this question. Not gonna lie, like, I don't know how to do this question. And I have a feeling that the half the state doesn't know how to do this question, or more than half the state. Chat, how many of us got cooked in this question? One's in chat if cooked. One's in chat if cooked by question 13A. Bro, no bro, I've tried 2 different subs. I'm about on my 3rd sub and I still can't do it. Okay? So why don't we just do it brute force and just be like, hey, let's just be really boring and go x minus 1 equals, like, x minus m plus 1 equals u. Like, I just don't see the minus 1 appearing from the A. Like, what am I doing? This thing. We'll cross this out. Now we'll leave it there. We'll try it, okay? So when x equals to m minus 2, u equals to minus 2. When x equals to m minus 4, u equals minus 4. Why don't we just keep writing that? I just feel like maybe we can get somewhere with it. I'm not so sure. I'm not very keen. So you got u plus 1. Yeah. U plus m minus u plus m. I know what's going. I'm starting, guys. Chat. I'm starting to realize what's going on now. I'm realizing what's going on. This minus sign has to happen. All right, guys. Now I know what's going on. So basically, the substitution that you're making is not this. All these substitutions has one thing in common, and it's u equals to x plus something, and it does not achieve the x to the power of minus sign that you really want to do. So what you're actually going to do, and this is going to sound super stupid. Are you guys ready for something really stupid? We're going to let u equals minus x, okay? And like by doing that, we can reverse it and go minus x plus m, because that's going to be the one that we want. This is the substitution, guys. Lock in. Like, how many people are going to get this? Like, less than 10% of the candidature. Like, honestly, on a 13A, they want a substitution this twisted. I can't. I don't have any words for this, right, guys? Like, x equals to, m minus 2. Okay? So, u equals minus m plus 2 minus plus m equals to 2. Yeah, now we're cooking. Everybody. Chat. What do you guys reckon? I think we're onto it. We got him. Holy, that is ridiculous. And then you got, like, of course, the minus sign on the du equals minus dx. Of course we got that. Okay, so out of that we got this. We got a 2 and a 4 and a e to the power of wait, we haven't done the e. X equals to u minus m. No, minus u minus m. No, minus u plus m. Okay, so e to the power of minus bracket minus u plus m. My goodness. And on the bottom, oh wow, x equals minus u plus m, minus u plus m minus m plus 1 minus du. But a du over here, it is a dummy variable, but that is not on, guys. I cannot even fathom how, like, someone in exam conditions can come up with this absolute junk. This is insane, right? Like, if you managed to dummy variable your way to getting the fact that it's minus e to the minus m times a, congratulations, you've got state ranks. Okay, that's what I'm gonna say. Like, that is just absolutely ridiculous for a 13A. What do you guys think? That is ridiculous. Okay, someone got the legit right, which is u equals x sub. Just King's rule if m equals 6. Oh, thanks, yeah. U equals x does not work, bro, what? Hey, guys. Yeah, look, there's probably a minus sign, but I think we've done pretty much everything we wanted to here. I can look at it one more time for you all, but I think this is the correct substitution. One's in chat if you got this substitution and got it to work. That's not on. That's crazy. I use the minus sign to reverse the 2, 4. And then I use the other minus sign to bring it up to the top. Okay, well that's 13A. That's just... That was brutal, guys. That is brutal. Rishon Koren got... Alright guys, let's not be mean to Iris. We're all comrades in here. Alright? Just Yotan says I did not get it. I did exactly what you did. Good job, Truffles. No, I didn't, bro. I did not get a state rank. Tim did not get a state rank. I'll get 1 mark for vibes. Bro, this question was not hard. Alright, stay plus sit. Question 16. Are we not even going to make it to 16 at this rate, are we? Okay, so question 13B. Oh man, 13B. What do we got in store for us today on 13B? Well, we know it's a unit vector, so x squared plus y squared plus z squared equals to 1. Okay, it's a unit, yeah, magnitude is 1. And then we can also say that the dot product equals 0, so we got a 2x plus 4y minus 3z equals to 0. And we got a minus 4x minus 5y plus 3z equals to 0. So to be fair, this is what I would personally do in this situation. I would plus these two equations together, because when you've got two equations with 3 variables, the best you can do is just come up with a like elimination, okay? An elimination of one of these. And this is chat, this is the reason why you do not do things like, oh, just make 0 equals 0. I'm sorry, like, if you fix up that habit in year 10, you will not be having an issue with this question. You do not do this, you do this. You eliminate them by adding. And you're going to get minus 2x minus y equals 0. That gives you an opportunity to go y equals minus 2x. And that basically allows you to chuck this into the original and have x squared plus 4x squared plus z squared equals 1. Now we still got a bit of a problem here, because can we do the same thing to turn z into x? Yes we can, but it's going to be ugly. Okay, I'm not looking forward to doing that actually. So we're going to try that on the new color, times by 5, 10x. That's a hard question. People don't do these sort of questions normally. Goodness. Oof. Okay, we're going to add them. So we got minus 6x. I hope I did my multiplication by 5 correct, honestly. Okay, minus 6x minus 3z equals 0. Z also equals, oh, that's nice. Minus 6x. Z equals to minus 2x as well. We chuck that into the other ones. So we got x squared plus 4x squared plus another 4x squared equals 1. And that's going to give us x squared equals 109. X equals to a third, plus minus a third. And we go back up and we get all of them. So when x equals to a third, y equals to minus 2/3, z equals to minus 2/3. That's pretty hard, I have to say. Like, and when x equals to minus a third, y equals to 2/3, and z equals to 2/3. So we got two coordinates, got 1/3, minus 2/3. Let's do the IJK form. So vector C equals to 1 on 3 I minus 2 on 3 J minus 2 on 3 K, or minus 1 on 3 I plus 2 on 3 J plus 2 on 3 K. And that is not that easy. I don't think that's that easy. Honestly, one's in chat if you cleanly got this out, because I don't think that's obvious. Like, being able to do simultaneous equations and managing all that while in exam conditions is not that easy. I may have done the minus wrong, Yotans. Bad luck. Oh right, well, Raincoast, hey, welcome back. Yeah, honestly, what do you guys think? Anyone got this? Any takers on this question? This was not What? We still on 13, chat. What is this? What is going on? Truffles on 1? Raincoast, yes, from the Advanced English chat. Welcome back. Hope your standard went well today, because I know that you were asking for standard. I didn't see magnitude of c equals 1. I am done something got 1. YZFBX got 1. I did this gra. I got IY. Nice question. Tell me where there are surely. Please give us the test. Yes, this was easy. Yes, this was easy. Okay. Iris, were you in the English chat as well? I can't quite remember. Now, hey, let's get up to 13C. Okay, so the first part we can just say, hey, x minus y all squared is greater than or equals 0 for all real x. Oh, it doesn't even matter for positive real. Like, because it's 2 marks, do you think like they're gonna get really iffy about the marking criteria for this? And you basically say let x equals to root a and y equals to root b, and obviously a and b have to be positive, but I really think that's a non-issue, honestly. Like what else can it be, right? Like I hope the marking criteria doesn't mess with people and just be like, oh, they didn't write the condition, but it's already part of the question, so it doesn't matter. I think it's fine, guys. So a plus b on 2 greater equals to root. Like, I mean, I think everyone knows how to do this. You probably could have done this quicker by doing something like this, honestly. Like, that's fine as well. Okay. This question was cooked. Yotans did not like this question. Yotans did not like this question. Holy. Bro, like 85 raw cutoff for E4. Yeah, retro, nah, that never happens. This was textbook except question 13. Really, retro? Okay, interesting. Retro reckons it's easy. Hey, Retro, you reckon it's that easy, huh? Interesting. Okay, let's have a look. Raincoat, standard was the hardest paper they've done. Not me, that's all the tutors, etc. are saying, but I didn't do too. Oh, okay. Hey, I'm really glad to hear that, man. Good to hear. 85's to low 70s? Yeah, maybe low 70s. Rage baiting. Retro's rage baiting. Yep, I think they're rage baiting. Okay, so for this one, what I want to do is work backwards a little bit just to see what we're actually dealing with, because guys, when you see like an expression like this, you do not want to like engage with the square roots. You want to show these square roots no respect, which basically means this. 0 respect to the square roots, guys. Never engage with the square roots in any question. They're not worth it. Okay? Just get out of there. And I am writing, like, you know, obviously not a true statement because I'm assuming the answer's true, but that's all part of the fun. Like, guys, when you're looking at this, you just think to yourself, sure, this looks like a slog to expand, but the payoff is worth it because you're going to cancel out all the cubic terms. So why not just do it? Like, there's no reason why you should be trying anything else apart from working backwards. So you got an 8n cubed. For the n squared, you got a 12 plus a 8, so we've got 20n squared. For the single n's, you got a 12 plus a 2, so 14n, and you got a 3 at the end. And that's going to need to be 8n cubed. For the n squared, you got a 4 plus 16. You got whoa, guys, that's easy. I don't know what's going on. That's 8n. That's 16n, and then a 4. Rearranging that, you're gonna get a 2n plus 1 is greater than 0. Or have I like lost a term somewhere? Because like there's absolutely nothing going on in this question. Of course, this is true for n is greater than or equals 0. Have I done something wrong with my expansion or something like strange? I almost feel like I have to do one more time on the expansion just to pretend I didn't like get anything wrong. So let's just check, okay, with the laser pointer. If it's that easy, 12n squared, 8n squared, 20n squared, 12n, 2n, 14n, 3. Surely. 8n cubed, 16, 16n squared, 4n squared, fine. 8n, 16n plus 4, yeah, alright. So I guess that's obviously true. So you basically now write the proof backwards. You say consider 2n plus 1, which is greater than 0, since n is greater than or equals to 0, which is fine. Okay, and then you say, okay, now we're going to add terms to both sides. We're going to add 8n cubed plus 20n squared plus, let's make it a 14n plus 3 to both sides. I'm just writing it backwards now, guys. There's nothing else going on in this question anymore. 2n plus 3, 4n squared plus 4n plus 1, because I just happen to magically know how to factorize this. And then I'm going to go 2n plus 1 over 2n plus 3 is a 2n plus 1 all squared over a 2n plus 2 all squared. And that implies that 2n plus 1 over 2n plus 2 is less than square root of the both of them. And you can say as left hand side and right hand side were both positive, so there was no issues with square rooting. Yeah, that wasn't too bad. That was question C of 13. Was 16 from Terry Lee for real? Much easier than 2022. Harder or easier? Much easier. Slight close to 2024. Is this Eddie Wu? I don't know. I'm cooked on for practice, but this wrecked me. Red Dragon didn't have a good time with this one. Okay. Let's have a look at question 13D. Evaluate this. With the substitution u equals to pi on 2 minus x. Okay, so they told us the substitution, so surely x equals 0, u equals to pi on 2, x equals to pi on 2, u equals to 0, and du equals minus dx. Okay, away we go. I don't know why they have it all in terms of u. That's really strange. Oh, okay, they swapped it. So it's 0 and pi on 2. We got a u equals pi on 2 take away x over 1 plus cos. No, let's do it a little bit slower. Sine pi on 2 minus x plus cos pi on 2 minus x dx with a minus sign. We'll bring it back up to the same direction as the other one. Pi on 2 minus x over 1 plus cos plus sine dx. And that's I. Well, guess what? That guy is also I, so we're going to have 2I equals, I hope we all divide it by 2 at the end. Like, I swear, like, do not forget to divide by 2 at the end, chat. Fortunately, we're still left with this integral, which means for 4 marks, we're going to have to resort to some t results. So t equals to 10 x on 2. So when x equals to pi on 2, t equals 1, x equals to 0, t equals to 0, we all got the dx equals to 2 over 1 plus t squared dt. So pi on 2, 0 to 1, 1 over, this looks like rocket science, but I assure you this is easier for everybody than the questions earlier. 1 plus t squared plus 2t over 1 plus t squared times by 2 over 1 plus t squared dt. Do not make me do a partial fraction. 2 over 1 plus t squared plus 1 minus t squared plus 2t dt. Okay, so these guys cancelled out to 2 plus 2t. Nice, and the 2's cancelled out too, so 1 on 1 plus t. 0 to 1 pi on 2. And that's still 2i, guys. Just watch out. So 2i equals pi on 2 ln 1 plus t evaluated from 0 to 1. It's pi on 2 ln 2 with a 0 on the other term. So 2i, and I equals to pi on 4 ln2. And that should be correct, if I'm not mistaken. That was question 13D. So that was the end of question 13. 13 was traumatic, guys. I would say 13B was quite hard. 13C, I personally don't think it's that hard. But like, if you decide to do something too conceptual, just bash at it. Just beat at it with this and with this. Like, these facts are like designed to be like that, because you're not meant to be thinking about, oh, they've got a gap of 1 and a gap of 2, so if I square root it, the gaps get smaller. No, don't worry about it. Okay, so we got question 14 coming up. Simplifies nicely. What is the average, y'all think? Let's have a look. Raincoats, this made me feel up, this feels made up to me as a standard student. What on earth is this? This is, yeah, extension 2 maths, they make this stuff up. Like, there's no, it goes up to question 16, but 16 is where we start struggling because we don't actually know what we're doing at that point. I'm surprised they put 2 dummy variable questions into question 13. Kind of right, yeah, you're true. Speed mixer, you're actually not wrong about that. I used T-formula for like 3 times in this paper. I love T-formula. I'm at 86 raw right now. What's that a line? Andrew Tam hitting an 86 raw. That's probably going to be a high 90s, like 96. Something like that, 97. This is literally like an essay. Yeah, we write a lot in extension 2 maths. Yes. Question 16C wasn't that hard, IMO. All right, we'll find out. Question, okay, this one. In equals to integral from pi on 4 to pi on 2 of cot 2n theta d theta. And they want to do a reduction formula with n is greater than equals 0. Now, honestly, guys, like, I know there's temptations to do, like, you know, by parts, but because of by parts, you're gonna like run into extra thetas and things. So the correct way to start this is just simply split off the identity amount of, and because they gave it as 2n, you can just be like 2n minus 1, and then you got cot 2 theta to the square theta here. Still does not make me enjoy doing this. We got 2n minus 1 theta. This one is 1 plus, how's it go? No, it's not 1 plus. It's like cosec squared theta minus 1. So just doing reverse chain rule here. Minus the integral of pi on 2. And that's in lower. That's like the lower level of in. So we all got this under control over here. D theta. Cosec squared, the question told you, was the derivative of the other thing. So we simply just going to get cot 2n minus 2 plus 1 over the new power, which is 2n minus 1, with a new minus sign, and integrate it and evaluate it from pi on 4 to pi on 2. And this one is simply in minus 1. And, well, we got to evaluate this thing on the top. So cot theta. What is cot theta? 1 on tan. What's 1 on tan infinity? Isn't that just like, it's like cos on sine, right? So that's just a 0 on the first term. And then like tan is just 1 on the second term. So yeah, okay. That's great. Yeah. Okay. And that's it for the first part. So for the second part, we only simply need to just sub it in. So let's try I2. I2 equals to 1 on 3 minus I1. How do you get I1? Well, we can say I1 equals to 1 on 1 minus I0, since they let you have 0. Wait, did they let you have 0? Yeah, they let you have 0 because it's I0. Great. So I1 is that. So I1 is literally 1 minus I0. So I2 equals to 1 on 3 minus bracket 1 minus I0 equals to minus 2/3 plus I0, which is the integral of 1. I hope you're allowed to do that. Sometimes I'm always suspicious whether you're allowed to do that or not. So chat, let me know if you're allowed to do that, but I feel like it's totally fine. So that equals minus 2/3 plus theta from pi on 4 to pi on 2. That. And that's going to be minus 2/3 plus pi on 4. I'm pretty sure I'm pretty sure I0 is allowed. I think this is fine, guys. Yeah. Okay. That's 14A. I'm sure it'll scale. Oh, it does scale amazing. Raincoast. It's like you can get around 70% and probably get like the top band. At least. Too many unforced errors from Ragnath. At least I remember to sub in for part 2. Yeah, that's a good exam technique. So only 3 hours. Did define IM for... It's fine, yeah. Like, you're allowed to let n equals 1. It's fine. Yeah. No, I like the maths is like one of those things where it builds up over the years, and you have to just feel really confident with all the earlier years of work to sort of like want to do extension 2 maths. Let's have a look at 14b. 14b, the acceleration of particle is given by this. So we've got a equals to 32 x bracket x squared plus 3. This is looking suspicious. Why is this in question 14? Displacement from a fixed point after t seconds initially has a velocity in a negative direction, really? Okay, and it's in terms of x. Look, you can do d half v squared or v dv dx. It's the same thing, right? I'll just do d half v squared. And I'm going to go 32x. Oh, let's just expand it. I don't know why they have it like this. 96x half v squared equals to integral of this. So you're going to get 8x4 plus 48x squared and plus c. And we know that when x equals 0, v equals to, oh, well, I mean, it's squared, so it's like, who cares, right? It's just 12, you just chuck 12 in. So we'll just chuck 12 in, 144, 72 equals to c. So v squared equals to 16x4 plus 96x squared plus 144. Okay, looks a bit dodgy to me. Something's up with this, okay? So that's what? Oh, it's a perfect square, really? Whoa. Okay, so v equals to plus minus the square root of 4 bracket. No, not 4. Let's make it a 16, actually. That's an odd looking question. So they just wanted you to find v. Oh. Okay. And that's going to be a minus 4 x squared plus 3, because you say that since, you know, x squared plus 3 is positive, and v is initially negative. So we're going to take that as our initial thing. So v is like initially negative. I just think there's something a bit dodgy about this. Like, why is it plus minus and why is it gone? Yeah, v is initially negative, so we'll take the negative side, because otherwise it's not going to work, is it? I mean, it's not going to give us the right velocity. Okay, so that's part 1. Part 2. Find the time taken for the particle to travel 3 meters from the origin. 3 meters. Oh. Dx dt equals to minus 4 x squared plus 3. 1 on x squared plus 3. Let me see if I remember how to do inverse tan integrals. Inverse tan of x on root 3 with a 1 on root 3 at the front equals to minus 4t plus the constant term. When t equals 0, x equals 0, c equals 0, 1 on 3 tan inverse of x on root 3 equals to minus 4t. I think you can just sub in x equals minus 3, isn't it? Because you're initially moving in the negative direction. So that's just going to give you a third. Otherwise, you're going to get negative t, and that's just not even possible. So inverse tan of minus root 3 equals to minus 4t. I just think something's really dodgy about this. Like, why? Why is this question here? Negative, since it's inverse tan function, pi on 3 equals to negative 4t. So t equals to pi on 36 seconds. Anyone got pi on 36 in chat? Anyone? Pi on 36? I just don't know how accurate I am with this sort of thing. Pi on 36, everyone. Part 2 is Doge, you reckon? Krish Patel generally about to cry. Silly eye. Did maths evolve? I don't remember maths being this hard 10 years ago. Anyone get minus t for the next part? Like, I know it's wrong though. Yeah, that's because you guys forgot to sub in x equals minus 3. Because it went left, so it's traveled 3 meters from the origin. Oh, it's so sus. It's so sus. Your square root 3 became a 3. Did I? Really? No, I don't see it. Oh. Oh. Why am I dropping that stuff? That's insane. That's madness. Okay, so that's not it. That's not it. That's like 12 root 3 here. My bad, guys. My bad. Pi on 12 root 3. Anyone got pi on 12 root 3? Yeah. Nice. William, what do you reckon? Yes, nice. Ragnath, that's right. Pi on 12 root 3. My bad. Thanks very much, guys. It's another markdown for arithmetic error. Good one. Okay. So that's fine. Did anyone in chat get caught out by the minus sign on the x and got a negative time? Because that is kind of awkward for you. Show that w is a 7th root of unity. I feel like the way you prove something like this is you can say something like, since 1 plus w, you can do it either way, to be honest. I actually think if you do it like this, it probably works. You can say, hey, since w is not real, you could just multiply it onto both sides like this, since you're not multiplying by 0, right? So w is not real. Therefore, w to the 7 minus 1 equals 0. W 7 equals 1. Therefore, and if you wrote it backwards, to be honest, if you wrote it backwards, I think they'll award the 1 mark anyway. It's like a standard question, okay? It's a w is 7th root of 1. Okay, so let's have a look. I feel like I've seen this question before, though. I've definitely seen this question before. It's a root of the equation. Okay, find the other root. Well, we know that other root, beta, right? Alpha plus beta as a sum of roots is going to be, wait, how do I do this? Find the other root of this, give it in terms of, wait, no, we don't do that. We don't do that. To be fair, the working out of this can be a bit sketchy. I know that like 14, this one is 14 and it's a bit dodgy. Okay? I'll tell you what I think it is because B and C are real. So we know that therefore the other root of this is the conjugate. Guys, how do I do this? I can't remember how I do this anymore. Because you can't, like, you can't just be case specific and say that W is like the first root of unity. You kind of have to like just get the other ones. How do I do this again? Is a root of the equation that? In terms of the positive powers of W. And why am I stuck on this question? It's like a basic complex numbers question. My goodness. Alright, we're going to have to lock in and think a bit harder. I know it's all the other ones, but like, how do I say it? Huh? The other root is the conjugate of W plus W squared plus W4. What's the problem? I don't want to go through all the cases though, you know what I'm saying? Can we go through all the cases? Why do we like, Ragnath doesn't like it. Ragnath doesn't like it. I failed this question, Red Dragon Star. Take the conjugate of all of them. Yeah, I know. But you can't, like, what are you going to do about that? Find a numerical value of C in terms of the positive powers of W. Positive powers of W. How come I can't do this question, guys? Like, it's kind of crazy. And A is not real. Alpha is not real. Yeah? Hold up. 1, 3, 5, 6. Oh man, I'm kind of getting stuck on this question. I can't believe it. Like, why? What's wrong, guys? What's wrong? Then the product, the roots. Oh, we're getting like roadblocked by question 14, B part 2. Sorry, C part 2. I'll tell you what I think though. Like, I think it's probably like the 135 or 356, but I can't tell you why. Do you know what I mean? Like, I can't actually tell you why. I just know it is. Like, I know that whatever this is probably going to be the other stuff, but I don't want to go through all the cases for you. I think you'll get 1 out of 2 if you just do one case and get that out, like, honestly. But find the other root in terms of the positive powers of W. What am I not doing? Huh? How about we try this. And we know that that beta equals to minus B. I can't do it, guys. I can't actually do this question. I don't know what I'm not doing. Alright, yeah, okay. Alright, guys. I'm just bad. Like, I don't know how bad, but it's like, it's one of those things where like you just kind of, you've been rusty and you haven't done these questions for a while. But like, yeah, it's fine. It's honestly fine. Like, I would have just guessed all of this anyway. You know what? Cope, guys. I'm coping. Like, I knew it was 356, but I had to find a way to show it to you. Like, honestly. Yay. Okay. Like, I mean, yay. Great. We're so cool. There you go. Okay. Find the numerical value of C. So you simply just do the product of the roots. So that means you got to do the roots of unity. C equals to the product of these guys. I don't think it's that easy, to be honest, this question. It's not obvious. W3 plus W5 plus W6. We have to expand all of this junk. So we got W4 plus W6 plus W7, 6, 7. W5 plus W7 plus W8 plus W7 plus W9 plus W10. People are just like falling asleep here doing that. W4 plus W6 plus 1 plus W5. We've seen these questions before, haven't we, chat? Like, it's everywhere. Plus 1 plus W squared plus W3. We know that this equals 0, so the answer is 2. Oh man, that took longer than I thought. Yeah, but that's the answer. It's 2. There you go. Question 14C. Question 14D. Sheesh, 6-7 skull emoji, not the 6-7. All right, Renkos. Hey, thanks for checking in. There's a very similar. Yeah, that's what I thought. I thought I saw one in Cambridge. Silly A, 40s raw incoming, got cooked. Mackenzie says. I have accidentally guessed the expression correct and gotten it with very, very invalid working. Yeah, that's possible. That's totally possible, man. Because, like, basically, if you... Okay, guys. If you manage to say, let W be the special case of cis 2.7, and you did the conjugate from that into that, you reckon they'll give you 2 out of 2 for that one, chat? Like, if you just went cis 2.7 and did the specific case and did not touch this stuff at all. What do you guys think? 1 out of 2 or 2 out of 2? Opinions in chat for that one? 1 out of 2 or 2 out of 2 for that question? That's right. That's what I mean. If you manage to just use a specific case to get 3, 5, 6, 1 out of 2? 2 out of 2? That's what I mean, silly A. You know what I'm saying? Like, are they going to award 2 out of 2 for people who only did the principal, the first smaller principal argument? Probably a 1 out of 2 from SpeedMix. So yeah, I would agree. I mean, you know, yeah, because they didn't say it's the one with the smallest argument. Positive numbers are chosen so that 1 on A, 1 on B, 1 on C, and 1 on D are consecutive terms with a common difference of K. So 1 on B equals to 1 on A plus K. 1 on C equals to 1 on B plus K. What's going on here? 1 on D equals to 1 on C plus K? Huh? And show that. Okay, look, so we're going to eliminate K from this one. So 1 on B minus 1 on C equals to 1 on A minus 1 on C. I just think, and K is positive. K is positive. There's something up about that. There's something dodgy about that, but I can't see it yet. I want to get 2 on B equals to 1 on A plus 1 on C. Not liking the look of this, actually. And the other one, if you do it similarly, is you're going to get 2 on C equals to 1 on B plus 1 on D. We are nowhere near getting like all these other terms, are we? Something's awfully dodgy about this one. There's A plus D going on. There's all these like pluses. I think there's more than just doing this, guys. We're not going to get any marks for doing this, are we? No. You know, like the next thing I personally will try, just because like I know what kind of junk they're on about. Like, I'll tell you what I think this next thing I try is. 1 on C minus 1 on A has the same gap as 1 on D minus 1 on B. So that will give us... That's not easy. That's hard. But are we just going in circles doing that though? I feel like we're just going in circles. B plus C on CB equals to A plus D on the AD. Okay. I can't see it, guys. I ain't seen how we get rid of the products. Show that B plus C AD. B C AD. I can't handle this right now. I'm crashing out, guys. 0 crash outs in chat. Come on. Lock in. Why is there a K there in the gaps? Like, I mean, it's kind of an obvious like reason to this, right? I think it's like, but why? Okay, guys, are you guys ready to see the real disrespect I'm about to show this question? Instead of like writing all this rubbish, you know what we're gonna do? We're just gonna call the terms. Like, we're just gonna be like this A, B, C, D stuff just makes you think AMGM, but maybe they just think, oh, let's bait all these kids into doing AMGM. Nah, let's do that, right? Because then what you can do is you can be like, oh, 1 on B is the same as 1 on A plus K. So what that means is that I'm going to rewrite B as the, like, I can actually get B as the subject, guys. I don't want to deal with it anymore. Okay, I'm going to kill it, like, with fire. And I'm going to get A over 1 plus AK. And then similarly, we're going to do the same thing with C. We're going to call it A over, doing the same thing, plus 2K. So 1 plus 2 AK. I hope that's right. Yeah, that's right. And similarly, we're going to get D equals to A over 1 plus 3AK. So I managed to get everything in terms of thing. What's that going to do for us? Not sure, to be honest. Not sure, actually. Okay. We're just making up stuff right now. Just having a go. That's all that matters. We're just here to have a go. A. Okay. Plus A over 1 plus 3AK, because these B, C's, and D's are just in the way. You know what I'm saying? Like, let's kill them all. Let's go for like working backwards, because that's what I'm good at. I'm going to delete all the A's. So here we got a 1 plus 3AK with a 1 plus 3AK on the top plus an extra 1. It looks like that earlier question, to be honest, right? And here you got 1 plus 2AK and a 1 plus AK over here. That gives us a 2 plus 3AK on the top there, greater than 2 plus 3AK on that side on 1 plus 3. All right, guys, got him. Wait, not yet. We cancelled out some terms is all we got. Oh boy. Why? So what's the point? The point is now we cross multiply because we love working backwards, and this looks to be like one of those move all the terms to one side situations. So we're going to do that real quick. So we've got 1 plus 3AK, because that's the middle term, plus 2a squared k squared minus 1 minus, yay, and that is greater than 0. I don't see how people can get this question that easily. Like, what is this question? And we're going to write it backwards, but I think this question is very hard. And you just write it backwards. Let's skip writing backwards. Like, have I missed an obvious solution to this question? Is this question hard? That's hard. That's disgusting. Guys, I don't think that's an easy question. Like, how do you get 14D? Like, this is not something... Okay, Speed Mixer had an interesting method for this by considering LHS, RHS, and show it's greater than 1 by writing everything to... Hey, Speed Mixer, I literally did A and K as well. I did A and K. I got rid of B, C, and D and did A and K. That's not an obvious question. I don't think that's a question 14 quality question either. I think that's a 15, 16 at least. That's gross. The dismay I felt after the 2024 MX exam pales in character to whatever this is. Oh, Vivi, Sean, you have no idea, man. Oh boy. Oh boy. Crashing out and not even question 15, 16. Usually low 70s for E4. I think, you know, people can get high 60s for E4. The more I do this question, the more I do this question, the more I feel like it's more the 60s rather than the 70s for this paper. Like, I just think 13 and 14 has been a trauma bonding experience. What do you guys think, chat? Like, it's been traumatic all the way through. My goodness. My goodness. What do you think about this paper so far? 13 and 14 are so hard. Like, I tried all the previous NESA papers and they're not this hard. Okay? So I don't know how I divided LH and showed it's greater than 1. Yeah, fair. Okay. Yeah, but you have to engage the K in that question. That was so hard. That was disgusting. I just worked it out with a totally different... Oh, okay, that's good, Red Dragon. Yeah, but hey, 15, 16 had some freebies. I think 13 and 14 was unexpectedly hard. Yeah. I wish I could have done it in the exam this way. You mean like my way? I feel it's clean. I think it's pretty clean. Because you basically just committed to substitution method and deleted all the B, C's, and D's. Yeah, it's hard. I didn't like it. Question 15A. Okay, so hey, at least we can find the area of a parallelogram, right? So we got a 4, 3, minus 1, and we've got a 2, minus 1, 3. Who's keen on the projection method and who's keen on the area of a triangle method? Let's do the area of a triangle method. We'll get the magnitudes going. Magnitude of A is going to be 16 plus 9 plus 1 square root. That doesn't look nice, actually. That looks disgusting. That's like a 26. Yuck. And magnitude of B equals to the square root of 4 plus 1. They're about the same length of working, root 14. Okay, the angle between them is going to be inverse cos of the, that thing. 8 minus 3 minus another 3 over the root 26 root 14, unless I've done some really bad arithmetic here. Okay, but it's a show question, so there shouldn't be any problems. So we got inverse cos of, and it's positive luckily, so we're in the first quadrant, 2 on root 26 root 14, which we can actually simplify that down a little bit by multiplying it out and getting rid of the thing. So you got a root 13 and root 7. I don't really know how this is going to get us to those numbers at the end, but it apparently does. So, okay. Anyhow, is cross product even in syllabus? Yeah, average Dr. Do student. The differences are positive, so yeah. Yes. Oh, I was reading that. I'll check it out later. 187. Okay, so we got this going on. That's root 91. Why are we having a root 1 on 91? Am I like going insane? So in the triangle, the angle is 1, and oh, that's a terrible triangle. Root 91, and that's going to be a root 90. Oh, that's where we got that from. Okay, therefore the area equals to a half times root 26 times root 14 times by the sine of theta times by 2. There's 2 of them. So root 26 times root 14 times by root 90 over root 91. I am pretty certain that that's going to be a 3 root 10 times by a 2 of times by root 91 over root 91. And that equals to 6 root 10. So that was, hey, that was recovery, guys. 15A, recovery. We're getting some marks back on the board. That was cray. Okay, 15B. Simple harmonic motion about the origin with amplitude A. Amplitude A completes 2 cycles per second. When it is 4 meters from the origin, its speed is half its maximum speed. Find the maximum positive acceleration. It's just a lot of reading, right? 2 cycles per second is frequency equals to 2, period equals to a half. So we've got a 2 pi over n equals to a half, which means that n equals to 4 pi. Okay, for n equals 4 pi, great. Now the real question is what do we want to do? Do we want to do the v? I want to do the v. Yeah, let's do the v. V squared equals to n squared a squared minus x squared. So v squared equals to, and it's quotable, you're allowed to quote this, 16 pi squared times the amplitude capital A, which it doesn't say. Huh. That's interesting, it doesn't say. So max v, so let's call that capital U or something. Okay, max v occurs at x equals 0. So at x equals 0, we got v equals to v squared, equals to 16 pi squared times a. I'm not actually sure what I'm trying to achieve here. Maximum positive acceleration during its motion. Amplitude a, 4 meters from the origin, its speed is half its maximum speed. Okay, so when v equals to a half of, I mean, let's just work that out. I kind of don't want to though. No, let's not work it out. Let's not do it. I'm just gonna turn that into a capital U. Half of u at x equals to a quarter. But we don't have amplitude, do we? So a quarter u squared equals to 16 pi squared bracket a minus a quarter. Okay, so we've got a simultaneous equation that we can play around with over here. What do we want? positive acceleration of the particle during its motion. So we want the endpoint, obviously. Right? So we want the endpoint. So let's get amplitude happening. So we just chuck the u in. So a quarter times by 16 pi squared a equals to 16 pi squared a minus a quarter. We're going to delete the 16 pi squareds. We're going to have a on 4 equals to a minus a quarter. Unless like I've missed something, but I feel like that's all it is. And then so that for a 3a on 4 equals to a quarter, a equals to 1/3. That's interesting. I mean, that's pretty like expected though. A equals to a third. So therefore you can say the acceleration, and it wants the maximum positive acceleration equals to minus n squared x, and it happens at the endpoint. So we're going to go minus, let's say, what was n again? 16 pi squared times by the leftmost endpoint amplitude of minus a third. So yeah, it's going to be 16 on 3 pi squared is the maximum acceleration on the endpoints at the leftmost endpoint. So that was 15b, I think. That's not what I got. 4 marks. You can work out the amplitude. That's maybe wrong. All right, guys. What did I do wrong? What's going on here? I've probably done some like dodgy substitution here. I can't see it though. Max speed. Max speed happens at the center when x equals 0. Half of max speed occurs when... Oh, I forgot to square it. Did I? Yeah, I forgot to square it, guys. I keep forgetting to square, guys. Oh, help me. Help me. Oh my goodness. Oh my goodness. Is that the only place? What am I doing? I keep forgetting to write squared symbols in this exam. I just don't, I can't even. Yeah. Man. 16. 3 and 4. Oh, 12? Amplitude is... How's that possible, guys? Am I like going crazy? Chat, am I going crazy? How's that possible? Let's try again. Let's go back again. We're gonna like put a line through all that because I am going crazy, and we're gonna go back and go v squared equals to 16 pi squared. Oh yeah, we didn't even have pi squared. I had no squareds anywhere. How do you do this? That's why like I was getting like all these weird, like I was unwilling to square root. That's just insane. Like usually, you know, this sort of stuff doesn't happen, right? It's like, and then you just go, oh, okay, so v equals to like why? Like this is a very straightforward question. I was thinking, why is this question so hard? Like why can't I get rid of a? You know, like what's going on? And then you just think, oh wow, he is really cooked. And then it's just like not happening. Squared, guys, squared. I'm going crazy. Okay. I hope I get it right this time. If I don't, I'm just gonna crash out. What? What? Oh, chat, what's going on? What's going on? How can that happen? How can it happen? I can't see it. I can't see, like, why is there? I'm not subbing in stuff correctly. Am I, like, what's going on? Let's try a different kind of algebra. He's not going to make it to question 16 at this rate. What am I worried about? I can barely do maths, guys, anymore. How can the amplitude be smaller than like the 1/4? What am I doing, chat? What am I doing wrong? But like, how is that possible? Oh yeah, that's fine. That's greater than 1/4. Oh, holy. Oh, wow. Because I was worried about this. I was like, oh, surely 1/4 is bigger than 1/12. Surely, right? Surely. My gosh. Yeah. It's this value, whatever this is. It's like 8 pi squared on root 3. All right, let's forget we did all that. Chat. That's fine. It's fine. Everything's fine. You guys want to see something cooler? You guys ready? Ready, guys? Ready? Ready for question 15C? Sometimes you need like a bit of a second wind, you know, like when you, not that kind of wind, just second wind, you know, when you like just realize that like life takes on a different dimension and you're like, you don't have anything to prove anymore. You've already cooked your exam, and then you come up with something like this, you know, and then you just think, yeah. And then you just think, I am so cool. And then everything's okay again. Wait. Do I want to do this? Yeah, okay. I'm still struggling though. I actually forgot how to do. Guys, chat. I forgot how to do this. Oh no. Like how do I do this again? Oh boy. Is this even doable? Or am I like just, I'm going crazy, guys. I think I'm going crazy. Anyone still want to play? Like, we've got 3 marks to do this in 2 lines. Hold up. I can't see it. I forgot how to, guys, I forgot how to do this. Can I be honest? Like, I forgot how to do this. Oh, guys, I can't believe it. This is fine. This is fine, guys. Listen. You don't understand, chat. You don't understand. Like, I'm an experienced mathematics educator, and I know how to do this. Oh yeah. What am I doing, guys? Guys, ready? On the top, that's just the sum of the conjugates. So it's just 2 cos. On the bottom, it's the same thing. We didn't need this line, by the way. Let's write another line. Guys, this can be done. In like 2 more lines. Ready? Watch this. With a minus sign, sorry. Do you guys know where I'm going with this? I think you know what I'm going with this. Everyone knows what I'm doing now. It's over. So the top is 2 cos pi on 2. And on the bottom, it's minus 2I sine pi on 2. Since z plus z bar equals to 2 real part of z, and z minus z bar, just in case the marker's not convinced, yeah? 2 real part of z, sorry, 2I imaginary part of z. Guys, 3 marks. There you go. Oh, club doing this method. 0 crash outs, he said. Oh dear, oh dear, oh dear. There we go. Club, join the club. The cool kids club. Yep. Of course, you can always realize and you can do double angle formulas, etc. Right? That's fine. Okay. Using De Moivre's theorem to show that the 6th roots of this are given by this. Yep, that should be okay, shouldn't it? So we got z6 equals minus 1, which equals to cis pi. Therefore, we can say r equals 1, no one cares. And 6 theta equals to pi plus 2k pi, where k equals to 0, ... up to 5, because there's 6 of them. And simply just go theta equals to pi on 6. I think they factorized the 2k plus 1 on the top, so we'll do the same. And therefore z equals to cis, and they're not going to take away marks for you writing cis, so don't worry about that, over 6, and that's good for k equals 0 to 5. Okay, so a lot of free marks in question 15 at least. That's not too bad. Number 3, hence or otherwise show that the solutions to this are. So it seems like this looks like the numerator of the other one. So we're just basically letting z equals to cis theta, because that seems like what you're going to get. So you're going to get cis theta minus 1 over going back up to the top, yeah, cis theta plus 1 to the power of 6 equals to negative 1. Now from part 1 you can simply just match them up. So I'm just gonna get, like, from part 1 we know that cis theta plus 1 over 1 minus cis theta equals to I cot pi on theta on 2. So I think by flipping it, they're gonna go like 1 on I cot theta on 2 with a negative sign extra is what we actually want. So cis theta plus 1, and that we can simplify that by just doing the i's on the top. So we got an I tan theta on 2 to the power of 6 is equals to minus 1. Oh, but they stuck to I cot. Why would you do that? That's so rude. I was just trying to be nice, trying to get you like, oh, it's so annoying. That's so annoying. What am I not doing now? Okay, so it seems like they've got all these angles, right? And that's all like k equals to zeros and stuff like that. But what's the deal? What am I doing wrong? I was about to just solve this, but I feel like the question has a more direct substitution that I want to check out first, guys. So, nah, we're gonna solve it. I don't think there's any other way. So let's just gonna go minus I. No, minus. No. I don't feel good about this. I don't think we should be doing this. Because like the question said z equals that, and why are we doing like that? I just don't feel good about part 3. I want to try again, except this time I'm just going to go straight to z equals to I cot theta. You know what, or even theta on 2. Because I just feel like that's probably the right hand side. So we got 1 plus cis theta over 1 minus cis theta. I'm getting like stunned by these questions. I don't even know what's going on anymore. But yeah. And what about them? We're gonna rearrange this. It's not that obvious, is it? Okay. I think that's what they wanted. And we wanted to solve this. What sort of marking criteria would they be? Because what if you just kind of like listed those angles and that's a quarter a day, and you just said z equals all those things? How would you relate this to the question? I feel like they want to see this kind of thing going on, so therefore z equals to I cot, etc. Okay, so I mean, yeah. What's the marking criteria for this, guys, for number 3? I feel like this is mandatory. If you don't make this correct substitution of z to match, like, and to try to engage part 1, I don't know. Like, is there a way that people did it? Did they find manually all the angles? And because I used it in the wrong way. Like, I actually found I was about to find all these angles myself, and find a lot of them. And I don't even think I'm getting them right, because that's theta on 2, and like that's the values of like theta. Then I have to like divide it by 2 to get I cot. Like, it's not right. Yeah, I don't think this way would have worked. This way would have totally not worked out for me to even get those angles going. So interesting. Okay, so what do you guys reckon, chat? Like, that was a weird question. I'm weirded out by this. We'll find out on results day. Not really point speculating. Not you can change your mark. Still be in E3 range, low 70s. That's a bit low, I think. I think it'll be over 70. Ooh. Lock in for 3U. Real. What do you guys think about that question? That just happened. What raw percentage of mass is considered like extremely good in extension 2? Yeah. I don't know. What do you guys think of that question? I find it's a bit out of control. Like, I didn't like how they wanted you to use Z in that sort of weird way. I don't know, guys. I can't tell. Weird. Horace Pally reckons it's weird. Yeah, I just think like it's clearly they wanted you to do a rearrangement of that to get the thing. But what if I saw Z and I wanted Z to be like cis, and it didn't really get us to that point? It's very strange. I feel like this is something that you have to realize on the spot, that this is what the question wanted you to do. Like, if you didn't do this, you're going to be in trouble on that question. So I hope people did it. Question 16. All right, now we're on to the main event. We've got about an hour left to do all of question 16. Yeah. You tried it for a little bit and then moved on? Yeah, like, it was weird. I feel dodgy about that one. What was that? Question 16. Okay, so we got a series of terms, and we got like Zn, cos, and theta. plus z to the minus n minus 1 cos n minus 1 theta. Okay, talk to me, like what is this? This is very strange. I'm getting like some weird vibes from this, and I think like it all equals to, and oh, it goes right all the way down to just a single power of z and a single theta. Okay, fine. Where z is a complex number and theta equals to r, a real number. Okay, and n is a positive integer. Prove by contradiction and the triangle inequality, or otherwise, prove that all the solutions to the equation lie outside the circle on the complex. Sheesh. Okay, let's set up the contradiction. So we're going to assume it says all solutions lie outside the circle. Okay, we're going to assume that there exists a z such that the magnitude of z, or the modulus of z, is less than a half. Okay, and we're going to try to contradict that by using the triangle inequality. But how does this triangle inequality even affect this here? So what we're going to do is we're going to chuck all this in. Okay, so what we're going to do is slam a massive this on the thing. Okay, and we're going to say that according to the triangle inequality, this is going to be, the left hand side is going to be less than or equals to the individual ones being split up. You know, you can like split the first one and you can say the rest, but after recursively doing this, you're basically going to have this cos n theta plus z n minus 1 cos n minus 1 theta plus dot 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 all this, right? So by the way, the left hand side equals 1, so we know that 1 is sort of like the target that we want to contradict. Okay, and over here we got a z cos theta. Okay, so what you're going to do with this is you're going to assume that it's less than a half. So we're going to say, since cos n theta, it's rubbish anyway, is less than 1, we know this whole equation is probably going to be less than or equals to just all this junk. And it's just a GP. And you just kind of like go with the flow. You got this, you got an n-term GP. And like, and you basically, oh, you can even take the magnitude out, so you'd be like, hey, that, dot dot dot, that, and that's gonna give us a initial term of z with a ratio of z magnitude to the power of n. There's n of them, minus 1, over the thing. What's the other thing? Okay, so what you're going to do is you're going to say, hey, since we assumed that the modulus of z is less than a half, right? We can like kind of just have a go at looking at the nature of this, because this can't be 1, guys. Basically, is what you're trying to say. So why is it not 1? Why is it not 1? I just kind of can tell it's not 1. But you know what we can do is we can say, so far we know that 1 is less than or equals to this lot. Again, working backward techniques. We times that to the other side. Okay, we're going to go to the n power n plus 1. Don't really like the look of this, but you know what? Like, I feel like that's not too bad. I feel like that's doable. So far we've just done triangle equality. Everything's still facts, right? So what we have is a like a polynomial, and this polynomial is unfortunately, you know, it's got something dodgy going on here, because we want it to be greater than 0. Why? So consider the polynomial px equals to x to the n plus 1 minus 2x plus 1 p dash, it's a stat point. Do we really need a stat point for this question? I'm just trying to prove this, like this stuff can't be like a half. I'm like, wait, what's the problem here? I'm getting like perfect square vibes off of this, so I'm just trying to check if I made an algebra mistake doing this, because we're on our last hour and we want to try to make some progress on question 16. Okay, so all of this, the causes don't make a difference to me. I don't care about them. I have all these terms, and I have this cos stuff, like cos is gone. And the triangle inequality tells me that this is greater than 1. So all this is greater than 1. And why? I mean, clearly this is not true. I mean, clearly. This is so false, like it's not even funny, but let me just explain why. You know what I want to do? I want to keep going with the non-polynomial idea. We don't need the sin z is less than a half yet, because we haven't tried to contradict anything. This is still facts that we're doing here. Okay, so here I'm going to introduce an extra term called z squared. I probably should have done a minus sign there. I've broken something so much here. I don't even know what's going on anymore. Oh, because that part's positive. We can't do that. Can't do that. I don't like this anymore. We're not doing that. We're backing it up. And I like my polynomial idea better again. We're struggling here with this thing. This is kind of dumb. Like, this is so dumb. Like, I know, like half. It's staring at you in the face. I just need to finish the reasoning, guys. Like, honestly, it's fine. It's totally fine. Okay? Like, why? What am I not doing right? 2 times a half minus 1. Oh, yeah, of course. All right, no. We don't need that. We don't need this. Okay? So we just, like, rearrange it. Yeah, we don't even care about the nature of this. You say, oh, since... Wait, what? That's true, though. What? Oh, what am I not doing right? No, we do need this. We do need it. Oh, man. Like, it's definitely like, guys, just imagine, right? Like, imagine you had a half and you take it to the power of n plus 1 and then you minus 1 plus 1, right? Like, clearly this thing is going to break the moment you go under. But why? Why is that the case? Or it doesn't really? Okay, all right. I got something for you guys. Okay, consider the case n equals to 1. We have 0 is less than or equals to but that's true though. That's true for any n. So I'm stumped. I'm actually not sure how to finish this one. We're going to come back to it in a second. We'll just write out the rest of 16 first and come back to this one. Oh boy, how are we doing for time? Oh, we've got about 15 minutes. I'm missing something. No, I want to spend a little bit more time on this, guys, but then I kind of want to also check the vector question at the end as well. What am I not doing? We're crashing out on question 16a, and I'm just like not seeing something. Cos. What's wrong with cos? When n, why is there a cos there? Something seriously dodgy about this cos that I'm just kind of like ignoring, like completely, and I shouldn't be. But I don't know why it's even there. Why is that there? Like something's about this cos, that this cos is so suspicious that I'm almost inclined to like do more with it. Because clearly, like we got up to this point where we're like, this ain't true. Why is it not true? Okay, let's try one more try. So attempt number 2. What we're going to say now is that these causes are there for a reason. Okay, I'll tell you what the causes are for. The causes are for z equals to cis theta. They didn't say let z equals cis theta, did they? They didn't really care about that, but we're going to care about it because they put it in for a reason. Okay, so cos n theta, we know that 2 cos n theta equals to z to the n plus z to the minus n. Okay, again with that fact, the conjugate fact. So we know that cos n theta equals to z to the n plus z to the minus n on 2. And by multiplying this, okay, by z to the n, we have a cancellation of terms that leads us to believe that it's z to the n plus 2n now this time, plus 1 over 2. It kind of looks interesting, okay? And what we're going to do is, after all the magnitude symbols, we chucked on all these magnitude symbols. So now we're talking as if 1, which is the left-hand side, is less than or equals to. Okay, it's less than or equals to, by the triangle inequality, the following things instead. And I'm going to give you the other guys as well. Oh, a 2 bracket n minus 1 plus 1 on 2. And the last term is z to the, I think it's just a single power of z at that point when you go down that much. Oh no, actually we multiply by z, so z squared plus 1 on 2. That's the last term. That's kind of interesting. And by the triangle inequality again, we got a whole pile of n's. We actually had a half times n on the end there. And here we've got the series, which is also a bunch of a half outside of. I'm feeling a bit better about this. I think we're onto something. Yeah. And of course we can do the modulus. So a half z to the n. Okay, that's the initial term. And then number of terms in GP? -1. Bro. So basically we have the same thing as before, but with some squareds going on than before. How fascinating. Why? What's special about this now? Very interesting though. And that's a 1. So this time, let's try to bring that over. I'm still not feeling 100% about this method. We're going to times a 2 and the denominator's over to the other side. The thing doesn't need to be there. Minus the 1. We've got the z to the power of 2n plus 2 minus squared. And then there's also like an extra n that I did not even bother multiplying by because I'm so silly. I just think, like, why? What's up with this? Can we just check something about this thing? Like, I really think that if I just took this particular bracket and I just pretended that they're all like halves, right? They're all just halves. So you got a half, and you got, you know, this entire geometric series, half to the 2n plus ... like half to the squared. I'm pretty sure that it will just not look that good. It will be very small. But how? I can't see it. Can't see it. We're gonna put like a pause on this one just to write out the projectile question. So we're gonna do 16b. We're tapping out on 16a. Okay, 16b. This one looks like kind of nice and easy, isn't it? It's like with a speed of 50 and an angle of theta below. So your initial velocity vector is basically, you got the 50, right? And you got a downward velocity and a sort of horizontal velocity of theta. So you got 50 cos theta, and you got a minus 50 sine theta. And you can simply use Pythagoras because sine theta equals to 3 on 5 leads you to cos theta equals to 3 on 4. So what you've got is an initial velocity vector of what? 3 on 5? 4 on 5, my bad. 3, 4, 5, guys. 30. No, 40. And that's minus 30. Okay, so we've got all that going on. We're going to do the x's and we're going to do the y's over here. The x's. So a equals to minus k times v. I'm not going to do subscripts. I'll do a first subscript for the first one, and this is minus k. Let's do minus 10 minus k times v of the y's. So for this, because we're doing the time equations, I'm guessing we're going to be doing dv dt. You know, in the meantime, I'm still thinking about the previous question. I'm not sure what's going on with that one. Okay, so across horizontally, we've got a 40 minus, let's see. So minus kt equals to ln like v over 40. And you're allowed to remove the absolute value sign because v is greater than 0 for x, not a problem, okay? And then we can go v over 40. We can go v. I'll just try to do the algebra accurately for this one because I don't think it's worth like rushing it. T equals 0, v equals 40. Sheesh. Surely there's nothing wrong going down here. Yep. Still shell-shocked by all this stuff. I think 40 e to the minus kt. And then we got dx dt equals to 40 e to the minus kt. So x equals to, integrate it one more time, minus 40 on k e to the minus kt plus c. And when x equals 0, t equals to, ooh, t equals 0, that's interesting. So c equals to minus 40 on k, because t e to the 0 is 1. So c equals to 40 on k equals c. So we got x equals to minus 40 on k e to the minus kt plus 40 on k. I don't like this topic. It's kind of like boring. Over here we're going to do the dy's now. dv dt equals to minus 10. By the way, because it's like a linear drag, you basically don't need to worry about like doing it twice, even on the way down. So all you have to do is just integrate 1 on 10 plus kv dv minus 1 dt. So we've got minus t. I used a k in the previous one, but unfortunately I can't here, so I just have to work with it. ln, we've got a 1 on k at the front, ln 10 plus kv. Okay. So because they wanted v in terms of t, we're gonna just like do it quicker. So we got absolute value of 10 plus kv is equals to a. No, we don't even need a yet. E to the c1. Okay, cool. So when t equals 0, capital V equals to, I'm getting brain dead from doing this, minus 30. So 10 minus 30k equals 10 minus 30k. We didn't have that problem before, did we? We got to sort of find a. I don't remember it being this annoying though. What? Okay, whatever. We'll just take that as a. So 10 plus kv this is like, yeah, literal brain rot. And we got the y dt equals the same. So y equals to this absolute monstrosity. I feel sorry for the marker that's been paid to mark this one. And I don't even plan to go back and check. Unless chat wants me to check. We'll check if chat wants me to check. When t equals 0, y equals 0. And therefore c is not even 0. C is this thing, guys. C is like minus bracket 10 minus 30k on k squared, if I'm not mistaken. So c is that. Therefore, y equals to this rubbish. K squared e to the minus kt minus 10 on kt plus 10. Okay, so now we're going to go for the Cartesian equation, which is pretty simple. So all we have to do is x minus 40 on k equals to minus 40 on k e to the minus kt. Multiply both sides. We've got kx equals minus 40, and then we divide the minus 40 over to the other side. equals to e to the minus kt. Lovely. And that goes all the way in there. Oh, but there's a t there as well. Are you serious? Oh, great. Let's write that out as well. T equals to minus 1 on k ln of this rubbish. Chat, like, is this futile? Like, why do we do this? Like, why do they even put this in the HSC? By the way, this is also in the Mastering Maths textbook. It's there. It's given it in a general form, and everything is there. It's just a pain. Like, I'm pretty sure I've made a mistake somewhere here as well. Like, I would suggest looking at some of those official solutions from like certain avenues as well, because I really, like, I'm not so sure how accurate all this is. Okay, squared here, ln 40 minus kx over 40. Who's going to mark this? Okay, chat, this is our Cartesian equation. Depends on the marking criteria. The part you miss, POV. Guys, if you find x and y, didn't sub it in to completely find the Cartesian, which is 3 or 4, 5 or 4. Surely it's 4 or 5. Maybe 4, not sure though. Cartesian just to fill the mark quota. Hey guys, is there a mistake? Is there a mistake in any of this stuff? Like, I really don't want to check. Any people in chat that's actually done this question afterwards and got like roughly this thing, like, or hopefully exactly this thing, because I don't want to do it again. What do you guys think? Any takers? I'm not doing it again. I'm gonna go and do question 16C. Well, attempt question 16C at this rate. We've well and truly crashed out over here. I'll leave that on the screen for a bit while we have a brainstorm of question 16C. Please let me know if there's a mistake. You got something like that, Club Blob. All right, sounds good. Sounds good. I'm gonna take that as a yes. Go back and solve 16A. No, brother, I have no new ideas for 16A. We're gonna do 16C. I'm getting on a mystery ATAR with this one. Sloppy question. Took me 2.5 writing. Yeah. Like, it's, why do they put us through that? It's like, it's almost like, I don't get it. I don't get it. The whole topic sucks. Like, last year they did a mechanics question as well. 16C is slop. Do 16A, you bot. Oh, PBL coming at me. PBL. Whoa, 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 whoa. Guys, let's settle. 16A. Nah, we'll move on like to 16C. I just want to check out the question. Consider the point B with 3D position vector B and a line. So there's a point and a line. And they are 3-dimensional. Yeah, okay. And D is 1, so it's a unit vector direction. Okay. And lambda is a parameter. Let be the distance, okay, between the point on the line and the point B. Okay, so I guess we just, like, if you're going for that, if you're going to like let this be the distance, like, you basically just kind of go like this, right? Like, because it's 3D, you know, you have to do this. Like, I mean, I don't know. I don't want to do it though. Like A is non-zero, so it's like, I don't really want to. I'm not keen on doing this question. It feels tedious already. Okay, so the distance is simply going to be A1 minus B1, A2 minus B2, A3 minus B3, and we're just kind of like finding the vector between them, minus lambda D1 minus lambda D2. I don't really think we should be doing this, but it's this thing. Why do we want to do this? We have no interest in doing this. Find lambda 0, the value of lambda that minimizes f in terms of... There, you can't be serious. You can't be serious. Yeah, okay. Yeah. do it. We've got to do it though. But why? I'm not keen on doing it that way. There's something else going on for 2 marks and I can't see it. Alright guys, so did everyone check like the last question, the resisted projectile? Like I just don't want to have it on the screen anymore. Okay, we're going to move on because you've had it on the screen for a while. So 16C part 1, I ain't getting anything useful here. Let me just think about it in a more conceptual level. So you got D is 1, and you got A is like this weird sort of thing, which is just anywhere. Okay, so you got a line. And you got, so A is the position vector, you know, of wherever it is coming from. I probably shouldn't put it there, but B is lambda 0 that minimizes the distance in terms of all this junk. Are you allowed to like just, it's so stupid, but like I almost feel like you are. Guys, ready for this? Like it's so stupid, but what's to stop them from kind of going, okay, here's position vector. So we got B minus A, right? And we're going to project that onto, okay, D, because we can. Okay, because D is the direction vector, and it's got like a magnitude of 1, so whatever. Okay, and what you're going to get is you're basically just going to get the projection, and the projection will help you get the ratio that's going to be the distance. So find lambda 0 that gets you this. So remember, this distance here is lambda times D, okay? Because we know that D, the magnitude of D is 1. So we know this distance is the lambda times, like the lambda is going to be the magnitude of the projection. That's all you need. Okay? So do we need to like say any more about it? Do we need to like expand it out? Do we need to do any junk? No, it's just this. Whoop-de-doo. Of course it is. It makes a triangle. It's just lambda is the distance of the projection because D is 1. Do they just want this as the answer? I don't know. Pass. Okay, moving on. What the freak, Huggy says. I dislike vector proofs very much. Yo, that's what I did at work. Club Lob. Oh, Club Lob is like a Chad. I'm getting like, you know, high 90s vibes from Club Lob just listening to him. Number 2, let P be the point with position vector. Yeah, so now we're like over here at P, and we're just chilling out in the, it's just projections, isn't it? It's just literally projections, but I can't believe they just asked for it. Like, like how can they ask for this as an answer? It's so unfair, okay? Like, what is that? Like, I can't understand like how they can just do that, because I know a lot of students who would have wasted a lot of time doing this thing up above, okay? And part 2, show that PP is to, one out of 1. Moving on. Guys, 1 out of 1. 1 out of 1. What is this rubbish? What is this rubbish? Like, how is this a good question? I'm not impressed. Like, of course it's perpendicular because the minimal distance, because we use that concept to find the, like, what? Like, what's up with that? Like, question marks. Okay, complaining about this question, I don't like it. Not a fan. Club Lob proved it twice. Hence or otherwise, find the shortest distance between the line and a sphere of radius 1 unit centered at the origin O in terms of DNA. Okay, so we've got a little sphere here. And we've got the line, which could be anywhere, this line. And we want the shortest distance between the line and the sphere of radius 1 unit Oh. So we got the origin and we've got a radius of 1, so we just need to find the shortest distance. You may assume that if B is on the point on the sphere, then OPB, oh no, duh. Like, they didn't need to tell us that, did they? Like, come on, okay. Find the shortest distance in terms of D and A. Well, we now know that B is a point. Let B equals 0, 0, 0. Therefore, the shortest distance comes from lambda equals to the projection of A. Do we want to do A or minus A? Does it really matter? No, it doesn't. Onto D, which is this thing. Oh, lovely. It's still an absolute value on the top, by the way, because we actually don't know. Lambda is A dot D, absolute valued. No one cares. And therefore, we have the point on the line is going to be A plus A dot D, but in an absolute value sign, D. And we know that the distance from that to the origin is going to be the magnitude of it. So, good. -1. Tick. Okay, that's done and truly dusted. We just need to finish one more question. Easy game. Alright, what do you guys think of this question? In two minds about it. Like, the amount of working required was minimal. Like, I have no idea. I'm beyond words. Like, I just think it's fine. Like the last question. That's literally all you needed to write to get 6. 6, guys, out of 100. Question 6 was ethical. What do you guys think? Like, did anyone agree with the solution? Fortnite Balls thinks it sucks. I think he forgot the piecewise. What's the piecewise? I don't really know what you mean. But am I missing something about this question 16? Like, is this just 6 marks just for this concept of the projection and the triangle? Because we didn't have to do anything. Horace Pie, like half an hour early while talking to chat. 16A was good. I haven't actually finished 16 yet. A started off cool, then was Descent into Madness. He forgot the look, I haven't done 16A yet, okay? I'm going to have a go back and have another go at it. Any comments about 16C? Anyone? What's everyone's take on this? Is this correct? Epic Matt's biggest fan account. I did the exact same thing where I assumed to minimize the distance. Then I got to part 2 and I was like, what? Exactly, my friend. Like I don't understand what Ness's intention is, right? It's like a please explain kind of situation. I don't understand. Oh, thanks for your name, by the way, Epic Matt's biggest fan account. Do you think the paper was hard or easy compared to normal? Consider if the line crosses a sphere or oh, thank you. So Minduck Nguyen reckons I probably only got 2 out of 3 for this because I totally forgot the other situation. Lovely. So case 2. My bad, guys. My bad. If it was like that, for example, if it went through the sphere, we're still gonna project it, and see, like. Guys, I wrote an assessment about this exact thing, and I can't believe I got by the same thing. Is that bad? Like, I literally wrote an assessment about the same thing earlier in the year. Ouch. Yeah, I think that's it. That's all you had to do. Like, it's still the same thing. Like, you just got a distance. That's all you got to do. Yeah. Good one. Looks correct, not a cat. Looks a bit too simple to be a solution for question 16, Mason reckons. RIP. Yeah, that's all that was, right, Huggies? I appreciate Min Duck Nguyen for coming up with that one. Now, let's have a look at 16A, because I think Club Blob reckons that one is a descent into madness. I think I want to understand the question a little bit better. So we're going to go on to 16A one more time and talk about it. Let's all sit down, chat, and have a little talk about it. So we've got, consider the equation. E equals 1. So this is a massive equation that involves theta. And theta is not really in any way related to z. They didn't say that theta was the argument of z, so we probably shouldn't be doing what I was trying to do before. That's the first thing I'm thinking about, is that we shouldn't. Prove that all the solutions to the equation lie outside the circle. These causes just look very bizarre. I just think there's something awfully strange about these causes. Why are they set up like this? I'm just like, I'm wondering. Okay, why don't we try this? We know that the left-hand side equals to 1, right? And we also know that it's less than or equals to by doing the thing like all the other things. Okay. Okay, guys. Sorry, there's an N there on top of the theta. Okay. So 1's less than this. And we have some more action here, because we're going to call this e to the I. But that's the same as what we were doing before. I don't want to use theta though. That's the thing. I don't want to use theta. I want to use a phi or something. But there's an R as well that I missed. So we're going to drag this away and talk about R. Because that's, we're saying let Z equals to R to the N. Sorry, Z equals to R to the EI phi. Okay? Yes, and all the other junk. I'll write the last one out as well for you guys. No ends on this one. I phi. Yep. Okay. So I'm still looking at this, and I'm getting a half Rn, which is the modulus of Z. This stuff over here just feels really kind of good. That's just like 2, right? That's just 2. Because what you have is like, you just have like 2 complex numbers. You just kind of like can break it up into a magnitude of EI blah versus another, you're just spamming the triangle inequality here, blah plus dot 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 plus a half r times blah, right? So what you've got here is you got a half, and these guys are all 1s because they're all 1s. So, and these halves got offed by the 1s, and there's another r here. So what you really got is Rn plus Rn minus 1 plus all the way down to r. And that has to be greater than equals 1. Oh, we got it, guys. All right. That's just a series of a half. Of course, if r was less than a half, then this series is clearly less than the limiting sum from advanced maths of 1 on 1 minus a half. Wait, that's 2. No, a half. A half minus a half. Tick. Alright, we got 16A, guys. We got it. That's like, yeah, look, I mean, okay. Alright, that's cute. That's cute. That's the hardest question, guys. I don't know between 16A and 16C what the issue is, but it's like contradiction. Yo. Alright, guys, alright. We cleaned up. I mean, we got about 4 or 5 marks of arithmetic errors earlier where I just didn't write squared. But, I mean, this works. This works for 16A, but you didn't need to pull out the exponential form. I just wanted to get rid of, like, no, because the cos worried me. Like, I just think you need the cos. You need this. You need this because having just cos and theta by itself. Oh, that's still less than 1. Okay, alright, guys. It's just less than 1. It's just less than 1. Okay. Alright, sorry about that, guys. Oh boy. Yeah, that was it. You needed the cos. You didn't need the cos. Yeah. No, like I was doing that before. I was doing that in my earlier attempt and I just missed something. Like, I had this. Oh, I just did not make the realization that this is just an GP of ratio a half. Like this is just a GP. It's less than, clearly it needs to be less than the limit to infinity of thingy. You know what I'm saying, guys? Like this thing. That. And that equals to, yeah, that'll contradict just fine when you put a half in. So once you put a half in, it's not going to be greater than 1 anymore. Wait, is it? Wait, is there more to go on this? Have I did it unbalanced? Wait, something's up. What? Should we at least like clarify that part? Because I actually don't think like, yes, this is smaller than the limiting sum of 1. Oh, it's fine. It's fine. You're literally contradicting the sum to infinity. Or even less than 1 if... Yeah, alright. This is convincing. I'm convinced, guys. I'm totally convinced now. I'm completely convinced. Alright, guys. Yeah. Would your attempt be a state worthy? If I didn't make any arithmetic errors earlier, and I'm not really sure what Ness is looking for on this one, if it wasn't for those like lack of square symbols and getting calculations wrong at the start of the paper, I think you can get a state rank with this, because we did all the questions. I'm just not really locked in with accuracy today, so I'm not really sure. It was close, I think. Yeah, Asa, I didn't realize that it was just sum to infinity at that point, and you're just balancing it. The cos thing was too cute, but I just think that why do they reach for the cos? It's so artificial, it's so arbitrary. I didn't really get why they went for it. State rank cutoff. I don't know what you need for a state rank, like 96 raw. Yes. What do you guys think, chat? Hey, can we get an like a what do you guys think the E4 cutoff is? After me working through this paper, I would say that the E4 cutoff will still be like 70 or a bit lower. I don't think it's gonna go past 70. It's not that easy. There's too much traps in the middle of the paper that we're gonna have like a lower average than you think. There's too much rubbish going on in the middle of the paper. Yeah. Yeah, well, Club Lob comes out with a 67. We expected that one. We saw that one coming from a mile away. What do you guys reckon? 67 E4 cutoff? All right, we're just going to all agree on 67. 6-7s in chat. Surely 6-7. Ragnath reckons 68. 6-7 E4. Yeah, 6-7 is the cutoff. Do you think the paper was hard or easy compared to normal? I would say that it's less stupid than the 2022 one. But I would say that these 16s are still a little bit unreachable, except the freebie that's the resisted projectile. I would say that there's a lot of dodgy stuff. I'll tell you which ones I think were dodgy. 6-7s in chat. Let's go. Ibby12 reckons 70. Yeah, 41 will be the E3 cutoff. Look, I think, okay, I'll tell you which questions I think are absolute rubbish, like, and bonkers. Starting from question 13, guys. This 13A was not easy. You cannot find this substitution very, very easily. Like, I think 13A is in the running for one of the hardest questions in a question 13 ever. Tell me if I'm wrong. What do you guys think about 13A? That was not a good time. Okay, so 13A rude. Okay, and what would a 95 raw scale to? 74 E4 speed mixer. That's pretty ambitious. Speed mixer. I don't know if many people that'll get 74 raw. Yeah, 13A could have been moved a bit later. 13A. They should swap 13A and 16B. Oof. Ouch. Ouch. Someone's mad. This one, it's a bit dodgy. Like, it's doable, but it's a bit convoluted. You just have to do your algebra correctly on this one, I think. 13B. It's still, yeah, it's okay. This one, I reckon it's pretty doable as well. So, yeah, you found M, the constant itself. Whoa. Is that even possible? I don't think that's possible. That's not. Yeah, exactly. Okay. So, okay, and there's like question 13D. Not too bad, 13D. 14A, not too bad. It's just like you have to know your like identities for trig. And yeah. 14B, not the worst either. There's something dodgy about 14B. Look, I think this question is a bit sus. I don't think they'll be giving full marks for just using W equals cis 2 pi on 7. I'm just saying. It's like a little bit dodgy. Yep. And then you've got this one. I think this one's quite hard, guys. 14D is hard. I think 14D is not easy. POV, you forget the magnitude of every vector is 1. Ouch. Ouch. Yeah. Yep. Oh, man. And then you got 15s. This one's okay. This one's not too bad. This one's doable. Like, no matter how you do it, you're going to get it. This one, a bit strange looking. The last bit of 15. This one, like, I wonder if, like, it's that's what they expected you to see, or if there's any alternate ways of doing that one. I'm not so sure. By the way, we still got 10 minutes left. We had 15 minutes left of this paper. 16A, not that obvious. 16B is a chore. And 16C, I'm not sure what they're thinking with that one. It's either too obvious or I've missed something completely. But conceptually, yeah, it is what it is. Like, but if you don't realize how to use that clue about the fact that the direction vector has a magnitude 1 and know what lambda does for you in that situation in this diagram, I think that would be a really messy solution if you attempted to use like A1, A2, A3s. Like the solution for 16C is this short. So, yes. That's what you're always doing for 16A because it's uni maths. That's crazy. Yeah, no, but real talk, guys. Like, I mean, Speed Mixer reckons this is on the easier side of the papers. I think there's enough in this paper that I don't think the E4 cutoff will be anything higher than 70. That's my opinion about it. But yeah, so I hope everyone sort of like didn't have the worst day, and you know, I'll see you guys next Monday for the Extension 1 paper. Appreciate everyone hanging out. I do want to make a shout out to NSW Maths. Just going to quickly write that in highlighter just right here. NSW Maths has this Discord where people who are, you know, you got a mix of university students who are studying maths, okay, and you've got a bunch of people who are also training to be teachers. Oftentimes when I see questions that I can't do, they look at that, and usually, you know, there will be someone who can do it and assist you with something. So it's a pretty good community. It's well moderated. Just a shout out to them. They've offered a lot of resources over the year as well. So that's something to be aware of. But other than that, I hope you guys have a good week and a good rest of the HSC with Extension 1 coming up. And yeah, all the best, everyone. All the best. Here's another year to another year. Catch you all later.